Med lyd.
Welcome to Refill 2025.
Thank you for attending. We are so excited to have you all here today. Whether this is your first refill or if you joined last year, we hope you will be filled with a lot of inspiration.
So this conference is all about learning, sharing, and recharging. So take in as much as you can, engage in conversations, challenge your thinking, and most importantly, have some fun. So be sure to notice that the entire program is on the website refillconf.com. There is also all the streaming links for those of you following at home. So follow there throughout the day.
We have a great lineup of speakers and plenty of opportunities to connect with each other. But before we dive into today's program, we would like to take a moment to recognize the team behind Refill. They worked tirelessly to make this event happen, and we would like to give them the appreciation they truly deserve. So please stand up, the crew of Refill. Woo! Come on, all of you. Isabel, Malin, Sara D, Sara H, Lotta, Nikolai, Rolf Anders, Julia, Sindre, Vegard, Ninja, Arash, Trym, Hilde, Marius, Johannes, Jørgen, Maciek, Emil, Tina, Kim og Marie. Woo!
Yeah, thank you all. There's a long list. So now let's get started. Enjoy Refill. And let's make this the best conference together and the best experience together. So please welcome today's keynote speaker, David de Leon.
Welcome. Hi.
Hello, and hello everyone online. We have a full day together, away from our homes, away from work. That doesn't happen that often, does it? So let's make the most of it. And the theme of this conference is impact. So how can we make sure that this conference has the maximum impact it can have on each one of you? And that's what I've decided to use this introduction for. So I'm going to do something a bit different. I put together a bunch of questions, and I'm going to have you think about those questions and write answers. So this is less a lecture and more of a group coaching session. I hope that sounds frightening. Don't worry about it. If you want to play along, then bring out a pen and paper, a mobile app, or a clay tablet and a reed stylus, whatever you use. So, how do you get the most out of a conference? Well, that obviously depends on why you're here. Do you know why you're here? Your boss sent you? Something like that. When people are asked why they go to conferences, they normally say, I go to conferences to learn something, or to connect with other people, or to be inspired. Did I touch on any of your reasons? Okay, good. There can be other reasons, of course, but I'm going to focus on preparing you to learn, preparing you to network and be inspired. But first, one thing. Let's get rid of some distractions. If you're anything like me, your mind is going, who's that guy? Do I recognize him? I should have gone to the toilet before. Where are they? And then you'll be thinking about work stuff and the milk that you're meant to pick up on your way home. So I want you to think about and just list all the things you need to do immediately after the conference. I want you to deal with these distractions. So, list work stuff, day-to-day stuff, or anything else that's going to distract you. If you've got a sore back, Write that down. So the point is to deal with all of that right now. And you'll get 3 minutes to do it. And I have some awful royalty-free music that you can listen to as you do that. And I'll be doing all of these things along with you. So, you can take down the music. So I saw some of you doing it. I'll get back to that later. Hopefully, you can be more present now. So just take a moment to look around. Just look around the room, see each other. Maybe just give your neighbor to the left just a nod. You don't have to shake hands or anything. And the neighbor to the right, just a little nod of the head. As you were looking around, did you notice where the emergency exits were? Because I'm obligated to point them out to you, apparently. So there are 2 emergency exits on that side. Take a look. And there are 2, or behind the palm, there's at least 1 emergency exit on that side. When I was a kid, I was told about some research that kind of stuck with me, that apparently people who scouted out where the emergency exits were, decided which one they would take, thought about the appropriate route that they could take towards that exit, were more likely to survive a fire or an emergency landing in an aircraft. So, once again, decide which exit you will take and which route you will take. As an adult, I can't help asking, how did the researchers know what the non-survivors were thinking before the accident? Okay. You want to learn something today. You want to connect. You want to be inspired. But why That's the question. What's the purpose in learning or connecting? I think knowing your purpose obviously makes it much easier to make decisions, to prioritize, to focus on some things and maybe ignore other things. Purpose. That sounds so grandiose. Like, oh, do I have to have a purpose, David? No, I think you don't, because you can also have small purposes. So my contention is that if you have a small purpose, and I'll get to that, that can be just as effective as a grand purpose. In fact, a small purpose can be more useful in giving you direction in your day-to-day activities. So bear with me. There's a few steps that we're going to take that will help you find your small purpose. And I think if you do this, the result is something that will serve you far beyond this conference. So first, the first task is quite simple. You will just list the normal activities in a week at work. Or if you don't have a normal week, then 2 weeks or 3 weeks. So you will list things like, oh, there's that stand-up, and there's a demo, and there's a meeting, and there's a workshop, and I have my individual time that I'm coding or designing or doing desktop research or whatever it might be. So the first simple task is just to list all your everyday activities. And honestly, if you don't do this, then this talk is going to be very, very boring. So that's one reason at least to do it. You get 2 more minutes of lovely royalty-free music. Now it gets more interesting. For each of those activities that you listed, I want you to think about what impact you want to have in that activity. For example, if you are attending a meeting, think about how that meeting will be different because you were there. So that could be, oh, when I attend a meeting, I make sure that we have some structure. Or, in a meeting, I'm the one who asks those questions that are kind of challenging in order to make sure that we cover all kinds of perspectives. Or it could be, I make sure that everyone's opinion is heard. Or it could be, I always ensure that we have clear actions, everyone knows what to do and who's supposed to do it. So that's an example of the kind of impact you want to have in this kind of small context. And you do that for each activity in your list. Now, there will be some activities where you go, I don't really care about this one, I don't have a strong opinion. Just skip them. It's enough that you can identify a few activities that you care about, where you can identify how you want to make that activity different. And if this is an entirely novel idea for you, then the better. So this is key. You get 3 minutes to do this part. Now, for some of you, you will find that the time for the exercises is too short. And for those of you, I just want to remind you, there's nothing stopping you going back to this and thinking about it in your own time, if you find it meaningful. And then for some of you, the time is too long. You're quickly done, and then you sit around waiting. And for those, I would just like to encourage you to push and persist. I think most people stop thinking too soon. Because when we keep doing it, we can discover something that we didn't know we were going to discover. That often comes after a period of time where things are stagnant and boring. But if you can push past that, that's when you discover something new. So, you have a list, hopefully, of things that you do. You've maybe thought about the impact that you want to have in some of those small activities. If you were going to describe this to a friend and say, I was at this lecture, this guy with the white beard forced me to do this, and I think the kind of impact I want to have in my everyday work is this. What would you tell your friend? Is there a pattern you can see in these different activities? So that's what I want you to do. If you are unsure, I just suggest that you guess. Because if you have something written down, you can always change it, you can react to it, and it's okay. No one's going to see it anyway. So take a guess and write something down in the next 2 minutes. What will you tell your mum? So you hopefully have a sense of the kind of impact you want to have. Let's try and apply that to getting the most out of this conference. And I'm suggesting that one thing you probably want today is to learn something. Okay, so you no doubt have selected the track that you're going to attend. I imagine you might have looked at the schedule and found a few talks that you find appealing, and you'll go there and hope to pick something up. And that's all fine. But learning is much more effective and much more engaging if you're learning for something. If you're learning in order to be able to solve a particular problem, or learning to be able to do something. So that is the question. What are you learning for? That's a very broad question. So to simplify things, we're going to tie it back to the impact that you want to have. So think back once again to those everyday work situations and think about what knowledge, skill, or behavior would enable you to have more impact of the sort that you wish in those situations. So you don't have to worry too much about the topics in the conference. Just think about what are some things that would make me more effective in the way that I want to be more effective. So you've taken a few moments to think about things that might enable you to have more impact. And that can be your filter for the day. And then obviously the sessions aren't going to be tailored to these particular needs that you've written down. But you can listen for a few things as you attend the talks. For instance, you can listen and just say, how could this thing help me become better and do better? Or Are there any phrases or metaphors or examples that the presenter is using that I could borrow and it would help me explain things? If you just feel that something kind of sparked something in you, make a note of it, even if you don't know yet why it sparked something in you. And clearly, write down anything you don't quite understand. Maybe you could phrase a question that you could ask. And it's great if you can think of something that you want to do or look up or explore. So after each talk, maybe just say, here's one thing that I want to do as a consequence of this talk. Now, every talk is not going to blow your mind. Some of them are going to be too basic for you or too advanced or just off topic. But there are still things you can do when you listen to a talk that was not made for you. You can think about, okay, this topic is different, but is there some parallel? Can I apply this in some way to the kind of things that I need? If I disagree with something, if someone is saying something that annoys you or you think is wrong, figure out what you don't like about it and then think about what you would do instead in your presentation. And if things don't make sense, again, write down some questions. And finally, think about things that are not really about the topic. Maybe there's something about the performance, the presentation technique, the visuals used, something that you can borrow. Whew, David, you're really asking a lot of us. You're giving us homework, you're telling us to reflect, pay attention, know what our purpose is. It's a lot to ask. We were hoping to just be entertained. Yeah, I'm slightly sorry, but that also means that you're going to have to be careful with your energy today. So in the breaks, make sure to move. When was the last time you put your arms above your head? I mean, for me, it's weeks ago. So maybe do that. Have a drink of water. All food and lunch will take place in the orangery, which is across from here. And if I dare say, maybe skip one session. Go for a walk. Sorry, organizers. Go for a walk, and you will be better prepared to make use of the rest of the day. You'll be talking to other people during the day. I know that a lot of you know each other already, but you'll also possibly be talking to strangers. I know that can be uncomfortable. That's this thing called networking, which we're supposed to do. So I'd like to give you some suggestions how to make the networking easier. And I think you'll have use of this today, but also your next dinner party. So, regardless of why you're networking, I think it all boils down to making a connection with people. If we don't make a connection, then why would you hire me? Or why would you ask me to do an assignment for you? So we have to make those connections, and we make connections when we like each other, when we have similar interests, maybe similar attitudes and goals. And the way that you find that out is through good conversation. How do we have good conversations? That would be nice. I like good conversations. Well, I have some tips and tricks. This one, if you don't remember anything else, then I hope you remember this one. When you're out in the different places in the breaks and you're standing around, maybe in a little cluster or a semicircle, leave a gap big enough for one more person to join you. That does two things. It makes it easy for someone to join you, but it also signals that you're interested in having other people come and join you. And I think this is especially relevant if you're kind of just hanging around with your normal pals. So leave a gap. Good conversations are always about something. They're not this turn-taking, just exchanging information. Oh, I work at blah, 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 where I'm a blah, blah. Oh, interesting. I earn this much money and I have a big car. That's boring. Good conversations are about something. And that means that someone says something, you either build on what they say or you challenge what they say, and then the conversation grows and becomes, it's a creation that you make together. I know that you've all been told to listen and probably told how to do it. The best way to listen is to not do something else at the same time. So as you are talking, I just listen to you and try and understand what you're saying and what your perspective is, and I don't compose my own answer. Because it's always, you might be going, I want to change the topic to this thing, or I have this opinion. Wait. Just listen and don't compose your own answer. And then when they're done, at that moment, that's when you improvise what you're going to say. And you think, that's going to be hard. Well, it isn't. If you're interested in them and you're curious about them, then the thing that will happen is you'll have a question. So that's what you're going to do. So simple. I wish everyone knew this. Think of the conversations we could have. Okay, I said that good conversations are about something. So I'm going to help you and suggest that you come up with 2 things that you could actually talk about. So the first thing, you're going to come up with 2 topics, basically. One topic is, what is something that I'm genuinely curious to hear other people's opinion about? Think about that and come up with a question. And then the second thing is, okay, maybe you have a reason for networking. Maybe you want to make new friends. Maybe you want a new job. Maybe you want recommendations of books and podcasts, or whatever. All I want you to do is to decide on one result that you wish for as a result of connecting with other people. So you have 3 minutes to think of a question you would like to get people's opinions on, and one kind of result of networking that you're after, even if it's as simple as getting someone's drink ticket because you want more, whatever it is. Here we go. So now you are prepared to attend this conference with intent. I think you're prepared to learn and make connections. But David, you said there were 3 reasons for coming to a conference, and the third one was to be inspired. Well spotted. Well, the problem with inspiration is that it doesn't last. And I have some thoughts about that, and I will share those with you at the end of the day when we all meet back up here for the wrap-up. Before I leave you, I also need to tell you what happens next. So you will all be attending different tracks. If you are part of the strategy and product track, you will go through that door. If you're taking the development track, you'll be staying in this room at least until lunch. And the design track will go out of that door, down a corridor, and take an elevator to the 6th floor. And there are people with refill t-shirts that you can ask, and there are balloons that will magically point the way, like a video game, which direction you need to take. And then after lunch, design will be in here and development will be on the 6th floor. So, I think you're ready to make the most of this day, and thank you for playing along. Thanks.
Yeah, perfect. I was told there was a video, so I was waiting for that. So first of all, who of you identify as front-end developer or front-end engineers in the crowd? Further up, I can't count it. So about half. That's good. This talk is for you. How many identify as back-end developer or platform engineers? It's also kind of for you, so that works out great. But it's called DevOps for front-end engineers. So I myself like to think of myself as a developer first and foremost. I've been doing programming for a while, and I like to think I'm fairly proficient all the parts of the stack. But if I'm being honest with myself, I think I have some sort of inferiority complex for backend and platform engineers and folks. And traditionally, ever since I started with like HTML, CSS, JavaScript things like 20 years ago, always heard that HTML, CSS isn't a proper programming language because it's markup, and markup is something else than actual programming language. So that's something I've heard for my entire career, I think. So imagine my surprise now in 2025 that the real same hardened backend developers is also the same that's surrounded by YAML and markup files every day. So now suddenly, apparently that's proper programming, unless markup wasn't just a few years ago. And I think that's because it's DevOps, and DevOps is cool, DevOps is great. So for some odd reason, DevOps, I think, is something that's mostly talked about from backend and platform engineers. So I think it's the most hardened backend developers that does metrics, talk about infrastructure as code, CI, CD, pipelines. But of course, that's not the entire picture of DevOps, and I think we'll dive into that. So let's see how what it really is. So DevOps is much more, in my mind, a tool for avoiding a bad production. So it's much more than just tooling and infrastructure. It's avoiding people standing there being left in the rain and having to act and so forth. And I guess every one of you have the same story. For me, it's like doing solutions and applications that's critical for people I know, my family that uses things I've also contributed to. It really, really embarrassed me when someone actually calls me and says my thing that I've helped created doesn't actually work. And I have no idea. It might work, but for some reason, some external party notifies me that something doesn't work. And that's a rough one. And so DevOps is a measure to avoid those types of embarrassing calls and having to explain to my family what I actually do. So it's much more about avoiding the rain and creating sunshine in our production environment. So as front-end engineers, we often do like critical things. We solve critical user flows. We solve something with high impact, both for the users themselves and for the organizations within. So we cannot only be meteorologists, but we need to be actual freaking skybenders to control the environment itself as well. Because front-end is complex, and it's production critical, it's user-facing, and DevOps is all about taking ownership of that production critical thinking. So I think DevOps is very much relevant for front-end engineers, but it's under-communicated and under-talked about within that segment of the developer community. So I like to think of DevOps as consisting of 3 parts. Some of you might argue that this is actually 5 parts, and I've cheated, but deal with it. So I think it's operational and productional responsibility is part philosophy and culture, and part methodology. So today we'll look into all these aspects and facets of DevOps and see how it pertains to the front-end engineers themselves. So it's much more than just one single developer handling a bunch of YAML files, but it's more a team coming together and improve the way they work. So DevOps is a team effort, and making sunshine requires ownership from the entire team. So production and operational responsibility, because the job is not done when committing code. It's done when we see the effect and wanted effect from the end user or the organization or the system we're working within. So, and it's a continuous work. It doesn't mean, just because it worked today, it doesn't mean it will work tomorrow or even the next second. So to maintain Sunshine, we need to understand it's something is within our control to fix, and it's within our control to have it working, and we have to take that responsibility. So not someone else, a third party, but it's our responsibility, or it's your responsibility. Luckily, though, it's the plural type of you, so it's you as a team, not you as a single person. So making that a team effort, I think it requires some cultural improvements for your team and the organization itself. If you want to ensure the Sunshine, we need to come together. So I think it's really important that it has to infuse like the cultural DNA of your team, because when things go wrong, you will act a certain way or react a certain way, and the more high pressure the situation, the harder it is to react. So having the part of the cultural DNA to act some certain way will help us do the right call when shit hits the fan. So when things go wrong, I think we will waver, but having it a part of the DNA and the culture itself, it's much easier to make the right calls. Because issues will happen and things will break. So philosophically, I'd say that DevOps on a higher plan is about flow, and we'll dive into that later on, I think. And I'll also say that it's methodology or process, because if we are to succeed in building a culture and taking responsibility, we have to grain it in some sort of like mechanisms to work. So I said that philosophically it's more like flow, and it's flow from a requirement over to realization. And if we want to build a good flow of that, we have to have some sort of structure to make that work. So I think that alignment in the way we work, in the way we act as a team, as a culture, as an organization, that requires some sort of system or some sort of method and process to work. So that's a tool for DevOps itself. So if we want to ensure like the everlasting sunshine in the production environment, we need to ensure that if there are any problems, or when there are problems, because there will be, we have to make sure that we detect them, that it's possible to detect. We need to see what the actual problem is. That's not given. And we want to see what it is as quickly as possible, because the time it takes for us to realize it and to fix it, that's a critical part as well. Hopefully, also we are able to improve it as quickly as possible, and to fix whatever is the issue, even if it's a misunderstood requirement or is an actual bug out in the production. And we have to be able to patch that fix as quickly as possible as well. So we need to detect it, find it, understand it, and fix it. And hopefully, additionally, maybe we could prevent that from happening ever again. So this is something we developers like to think of as flow-based development. So where we roll out changes and we observe the effects, so that's back again as a part of a feedback loop of verifications and quality assurance. So often we want to minimize the time from some requirement occurs over to that we can observe the fix of that requirement in the production environment and hopefully learn from that as well. And the reason we want to minimize this is because as faster, again, the quickly we can discover things and fix things, that causes less errors in production, so it maintains the sunshine. A subpart of that in DevOps is called the cycle time. So it's essentially the time from you start coding or start your first commit and able to observe that commit in production. And to reduce that time, just as a natural consequence of what we're discussing, to be able to fix things in production as quickly as possible, and you have to reduce the time it takes from you starting the code to it can be observed in the production environment. So there are a lot of consequences of that. We can improve that time and drastically improve our ability to make sure the production environment is in a happy state. So we can improve the time it takes to actually do the building part itself. We can make it easier to debug. We can reduce the scope of each task to minimize. So that means small changes. We can make sure we never have to do deploys at all. That's a way to reduce the time. And we can ensure that anything doesn't block us from doing a change, because that's often the case, that we are able to do some sort of fix and we know the fix, but we're blocked because of other changes that can collide with our intention change. So let's take the first part here. So improving the actual continuous integration, continuous development phase of it. I won't dive too much into this, but I think it's important for front-end engineers to also take a part of this. This is not like a platform engineering stuff. There's a lot of things to fetch on this, because you can leverage caching. You can have actively thinking of what kind of steps can you make in parallel. And is there any steps that's not critical for actual doing the integration part? So a lot of things that front-end engineers has to do and cannot outsource to anyone else. I have a story on this. At some point, we had an issue with an app, and it took 5 hours to build the app before someone on the team, namely Christian here, said this is too long, because when we discovered something at all, it took literally 5 hours before we can verify it in staging if it actually worked or not. And 5 hours is a long time to verify, and you say that, okay, it worked locally, but it didn't work in staging, so it would take probably 10 hours, and all it took was to actually try to think of the most cases we're doing deploys is just that part of the system, so we can change the way the CI works. And he reduced the running time, I think, from hours to minutes. And that's improved the flow, not in all cases, but most cases. That's the type of thing that we can control. If we have control of what we're actually doing, then we can improve the CI/CD flow. And this is true also, that's an app case, so that's kind of a special case, but this is also true in Kubernetes clusters and whatever, because sometimes it takes 30 minutes to do the entire clustering thing, and that's unnecessary because we just have the front-end part. We can swap out just the client-side stuff, for instance. We have to have some sort of notion of what we're doing, and then we can apply that steps. So instead of just accepting the default workflow for to try to make it conform into a Kubernetes type of thing that the platform engineering team has, we have to take control of our CI/CD flow as front-end engineer ourselves. And the simplest way to reduce cycle time, I argue, is to reduce the time spent for development. That's where you can reduce 5 hours from your CI/CD flow, but you'll still use 30 days from development time. So the easiest thing to reduce is development time. And I'm, of course, not talking about work harder or work faster, but work smaller. So to reduce the development time, you just have to reduce your scope you're trying to solve. So making small changes is key for being in a deployable state that can fix things and make us act quickly. I don't like being dogmatic, but ideally, and people on my team will probably say I sin on this all the time as well, but pull requests should ideally not be more than a day's work, probably. That's a rule of thumb that I break constantly. But the larger the changes are, the harder it is to avoid blocking, and the harder it is to like do coordinate across the team. No, I can't do that because I fixed things here. Yeah, when will that be fixed? Maybe in 14 days because we have to check this and this and this. So it causes everything to block, and it causes the code base to not be in a deployable state, which limits our notion to how to fix things quickly. So the simplest way is just to reduce the scope of each task we're doing. And I call it the simplest, but of course it isn't easy because it requires a lot from the team and it's hard work. So it's part technically it's a part technically issue, or it's hard technically to just like solve it, but it's also cultural, and from a method standpoint, it's hard. It requires us to think about sizing of tasks. It requires us to be good to scope down, and it's always natural to just, okay, let's include that, or let's include that. But it's hard to say that's enough and move on. So it requires a team culture, and it requires a team to work on it together. And I think it's odd in some way that we developers are happy to talk about developer experience a lot, and developer experience as an enabler of DevOps mindset. But I think we should also talk about the board experience a lot more, and take responsibility as a team for the methods and processes we do, and use a board as a tool to achieve that. Because I think that continuous delivery takes hard work across the board. As a pun. So when you have small tasks and small changes, you will firstly avoid a lot of blockages, but also it's easier to circumvent the blockages that may occur. So it's a win all around, I think. But it's harder to do, but smaller changes will allow us to be more confident when rolling out fixes. One way to do this, from a technical standpoint, is to use feature toggling. It will allow us to roll out code in production that is void. This part of the code is just mute. It doesn't do anything. It's there, but it doesn't affect anything, so you can be confident that it doesn't break anything. It will never be triggered or executed, so it doesn't do any harm. We can also split changes to be more granular, like this will work for some of us. And this is often commonly referred to as feature toggling. So just remove a part of the production code you have, but it's still there, but it doesn't do any harm. Here's a good example to do that in front-end projects. Here's using something called Open Feature, which is a standardized SDK for a lot of different feature toggling systems, because even though feature toggling in its like core is a simple thing, it's just toggle a feature. There's a lot of different implementation, a lot of different tooling for doing that. So, and they have their own APIs. Things like Open Feature use that so you can be interoperable between the different implementations, like the Unleash or Flagship or whatever. And it also has support for something you have to think about when doing front-end development in modern era. Does this run on the server? Does this run on the client? A lot of typical feature toggling systems, like if you're using Firebase and the remote config for feature flags, that requires you only to run in the client because it relies on Google Analytics and sniffing your email address under the hood, so you can't use it on the server side. But this makes it interoperable other implementations and easy to use. So from a consumer perspective, from this API, you just check, is this flag active? And according if it's active, do some code. If it's not active, don't do it. So ideally, this shouldn't affect the production code. And when using feature flags like this, you can also use it to say, like, I want to roll out this feature for 10% of the base, and if it's by some reason breaking, we can roll back easily. You can also do this like with just using environment variables. It's fair, but it's harder to do gradual rollouts. You require a deployment, which requires, again, is there any like if we were not good enough to do deploys continuously. There might be like 5, 6, 7, 8 changes happening before we can do deploys. So requiring and changing a feature flag that triggers a build or something, and maybe something's changed. It's harder to like just do the triggering. So there is always trade-offs. Do you want to introduce a new SDK and a new API for doing it, or just use environment variables? And both are fine, but you will miss out on gradual rollouts and things like that. Even if we do continuous development and we master the craft of having small changes, we do small feature branches, we do feature toggling, and we are quick to respond, and we have a good culture for that. We still need to detect issues that occur. So we need to keep an eye if there is a rain. And believe me, from Western Norway, there will always be rain. So we have to be on the lookout. So what do we do when the first sign of bad weather? So first thing that happens, we have to backcast. So like, what's causing this issue? Why is something not working right now? And not every problem can be easily reproduced locally. I guess you have had these issues, especially in front-end development stuff. But trying to reproduce it locally, and it's impossible to do. And we have no mechanisms, if we're not done properly, to find what's causing this issue and track it to the specific line of code that's causing that. So this is the art of doing this is often called observability, and observability and good observability is the key of good debugging in production environments. So the better observability you have, the easier it is to act when something goes wrong. And again, it's easy to stand here and say that this is required. And if you ask someone, again, on my team, we have zero observability on our client system, essentially. We have some sort of thing, but so it's easy and it's important. And I would argue in front-end projects, which is essentially like distributed systems with agnostic software and hardware deploy sources or things, is even more important because you have no control over the environment. But yet, I argue that the people having least focus on doing observability right is also the one that has the most complex issue to solve it. So I think myself included need to be a lot better at this because it's hard to reproduce issues, it's hard to find issues, and it's hard to do right, but it's worth the effort. So right now, I can think of 3 cases on the projects I'm working on that we are not able to reproduce the production issue, and we're just living with it. We're trying to improve logging, trying to improve things, but it's complex and reasons and whatever, but the fact remains, it's lacking observability at a good enough standard, and we're real people in Norway, buses driving, have a problem every day because of we have bad observability. So to be observable, we have to think carefully about tracing, logging, we think metrics, and so on. One example from an app perspective is breadcrumbs, where you can see what's causing an issue, here is an error, and you can backtrack what actions from the user has led to that action, that error. This is in SiteHub. You have the same in Sentry. You have the same in whatever, like error handling. New Relic is one, probably, whatever. You have a lot of examples that show you tracing or breadcrumbs over to what causes the issue. It's fairly quick to use, but still it's underutilized in a lot of ways. OpenTelemetry as well, for again, even if you have like some sort of a client-side solution and a server-side solution using an API there, it's hard to track where the issue occurs. So using OpenTelemetry now is easier to trace across different platforms. Again, I say it's easier, but it's tough as shit. So it's hard to make right, and it's hard to understand, it's hard to use, but it requires us to actually try to improve it. Another thing I think is underutilized and I've used previously, which is nice because having to have some sort of relationship with how your system is running in production for end users is important. So we can use things like Core Web Vitals and just pipe them to whatever Prometheus or whatever data source for Grafana and make metrics and notices on when things goes wrong. For instance, how long does it take before the server even responds? How long does it take before you get the first image or the first content? How long does it before you can interact with said content? These are important metrics from user endpoint, and it should be important for us as well. And this is something that's hard to do because we're sitting there developing on 40,000 kroners laptops that responds very, very quickly, and suddenly we're running it in across different people that has less computer power, and it doesn't act the way we think it acts. And this is a really quick win to do. This is all it takes, essentially. You have to do some fail checking and whatever, but and you have to, of course, set up things like Prometheus and Grafana, but essentially it's easy to do. This is an example from Next.js. You can just have Next.js send all core vitals to your Prometheus data source, and it will track it all the time across all your different users, and you can utilize that to make metrics and do notifications and whatever. So it's a quick win, but I think a lot of people don't do it. So what's better than being able to act and detect issues fast? It's preventing them in the first place. So trying to detect as much as possible early, and avoiding to have to do the reactionary causes as well. So this is often called a shift left approach, where we try to find a lot more things in the early parts of the development flow based. This will also contribute to closing the feedback loop faster. So the closer the feedback loop, the more issues you will prevent in a way. And what's often used for this is a testing pyramid. So we're starting with unit tests, the fundamentals of testing, and we do integration tests. We do end-to-end testing, which is the holy grail of testing, the all-powerful Illuminati top eye of testing. So it has the potential to catch a lot of relevant issues, bugs, and testing individual parts, more than testing the individual parts, because you're testing the entire system instead of just a single part. So you're testing the edges between the parts as well. And starting out with it feels really powerful, like testing if some title is set correctly and you run it, and it's run in 3 different browsers. It gives you a thumbs up. This works. It's set up correctly. Fantastic. But in real life, test looks more like this. There's a lot more async requests in the background. You have to wait from some particular state here. If that state is and it's very, very harder to do in real life. And you have to often rely on doing login and authentication in a way. And so you have the choice, should I try to make a specific environment for running end-to-end, but then you break the principles of having production near environments as well. And more often than not, this is what happens when running end-to-end tests. It works, and then it doesn't work, but it works, and it doesn't work, but you never know really when it works. So it's flaky in nature. So when pushing into your CI, you hopefully make it work, and if it works, it's only temporary, because it will break at some point. It's much more false negatives in the end-to-end tests that it needs to be. But luckily, because it's really, 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 really hard to make end-to-end tests work, I promised in the abstract I will finally show you how to do end-to-end tests. So instead of investing a lot more time, I think the solution is to focus not on end-to-end tests, but focus more on integration tests. So the solution to end-to-end tests and I will say, by the way, that this is only true for front-end projects that are complex, because Doing this, for instance, in the API, it's simple. Anyone can do it, even backend engineers. Unnecessary. But on front-end projects, there is a lot of different mechanisms at work that's not just an API, so it's a lot harder to do, both in the front end of things and in the back, because you have different dependencies back in the hierarchy of your system, and there's a lot of things going on in the front. So I like to think of, and coining the term, I think we should only focus on the testing burger instead. So focus on integration tests will give you much more bang for the buck in a case of being a trustworthy source to detect if something actually works or not. Because you can make end-to-end tests work in a front-end context for some time, but at some point you just lose faith that it actually catches any errors. And this will have the kind of the same semantics and kind of the same use cases, but it just drops the actual interaction with the design, and you spin up a virtual DOM representation and act on that instead. So I argue that it's kind of like testing an API itself. So even in end-to-end testing for APIs, you won't have some sort of robot trying to navigate your Swagger file and detecting the documentation. So there is a point at which you define this is end-to-end, and it all depends on where you're defining your end to be. And I think that integration test is more stable. It's more, it gives you more confidence that you can catch actual issues. And it's a lot easier to do, and it's a lot easier to run as a part of your CI flow. Speaking of that, there are other ways of testing as well. We have an example. We were launching a new Variant.no for a couple of months ago, and I think it was 4 days before launch or something. Just happened to see, like, is this loading slowly? And it's at some point we included the wrong package, which causing the bundle on the client size to be 12 megabytes large. So we included the entire Sanity Studio. So every time someone visits the site, it included 12 megs of the JavaScript, which is unnecessary, to say the least. So this could be caught with of course, better processes as well, but shit happened. So this could also be automated by using things like Lighthouse CI, and that's what kind of like using the Web Vitals thing. It would just see what's the response time of this. Does this increase? Here I have an example running it locally, but you can also run this on a preview branch, for instance. And I argue that most front-end projects should have preview branches, even though it's hard to do in a Kubernetes setting. It gives so much value to verify your implementation to stakeholders or to yourself. So it's worth the effort to have preview branches, and then you can do things like Lighthouse checks on it. And that it has some sort of the same problems as end-to-end tests because it requires authentication and somewhat, but the results of running this are far less likely to do false negative tests. Other tests that are relevant as well is doing PALI tests or accessibility tests at a CI level. It won't catch all accessibility issues, of course, and it won't catch the accessibility issues you've introduced as a part of your the original concept or whatever. So, but it at least catches the dumb mistakes that we do, so we can use less time on fixing stupid issues and more on fixing actual user issues. So ultimately, I will say that DevOps is about ensuring production and that it works as expected. And to do that, we need to see that what happens in production, what's causing issues, how that backcasts to the code as well. We have to change some of how we code things. And I also argue that we have to have some sort of thought on the architecture of our front-end projects as well, because what we do in front-end projects, it affects how thing works in the deployment state and the operation states. Things like, should it use a CDN? Should we have some sort of front? Should we bundle like this? Should we configure bundles to be loaded by different places? And so architecture we're choosing also affects the operation parts of it and makes it easier or harder, depending on what we choose. But we also need to mitigate and verify in code and take responsibility of testing there. But first and foremost, DevOps culture is often like people plus processes, but we need to build some sort of a culture to take the responsibility and taking ownership. And that should be the fundamental reaction for every developer to take. This is not a problem that occurs and someone needs to fix it, but we have to fix it as a team. To do this, we need to avoid big launches, and we should be brave enough to do continuous deployment. And again, I think front-end developers also sin as much as the next one at this. And it's easy to just collect a feature after feature, and this isn't big enough to do release. We require a lot of manual testing, whatever. But more often than not, take down the scope, take down the issues, and increase the amount of deploys, and you will avoid having to do a lot of those tests. But it requires some sort of active mental state to do this. It isn't for most people, I think. It isn't like the gut reaction. So we have to build that gut reaction into the culture. So the combination of production and operational responsibility, the methodology, the philosophy, and the culture comes together, I think, as is on the DevOps part of thing. So think of that and it's definitely in your wheelhouse to do. For DevOps, for front-end engineers, we build a culture of responsibility. We tighten feedback loops, do quick minimal changes, optimize for flow. And again, don't be afraid to deploy, even though it's easy to be. Take control of tooling and understand why we automate, because I think it's important to not just automate because you think of that as a good developer experience or whatever, but what's the intention of our automation here? Is it to discover some issues earlier? And the same goes for instance, linting. Why do we lint? What do we lint? Is it to avoid style issues, or is it to catch things that actually can break our production? This is within our control. And especially, I think, DevOps mindset is important for front-end engineer because we are developing distributed systems that is very hard and a lot more complex than I think we give it credit for. So I think that not only is front-end engineers that we should care about DevOps, but I think it is for front-end engineers, and DevOps should be a part of our core value. That's it. Old URL, nothing updated, but thanks for now.
Hello. Welcome to this talk about how we recreated the Elkjøp sites in the Nordic, and also how to improve the performance. I will talk about two things in the talks: why, how to drive change in a large enterprise. Just for some background checks, are most of you consultants? How many are consultants? Yeah, so like 98%. That's good. I think some of the things I would talk about in that first part will definitely be relevant for you as well. I've been working as a consultant for 10 plus years, both in Sweden and Norway, and I hope it can help you, those parts well, to actually try to make an impact in the customer where you're working. And the second part, of course, will be more into why we choose Next and Vercel and how it played out. So Elkjøp is the Nordic brand that we have. We also have Elgiganten here in Sweden and Denmark, and Giganti in Finland. We are by far the largest electronic retailer in the Nordic, when we have a lot of stores, etc. And when I joined Elkjøp, we had just released, it was 5 years ago, we had just sort of released the first version of the new site. I was not part of that team, and I think it iteratively improved over the years. But like about 2 years ago, it was not uncommon that you can end up with a screen looking like this for 20 seconds. It was not always like this, but happened frequently enough. And I'm all for like having some dynamic content on your page, but I think this for 20 seconds with no price and whatnot, it's not good enough. And I myself does not have patience enough to wait there. Of course, if you have good enough offers, customers will stay, and I do think we have a lot of good offers a lot of the time, but it's not good enough. And also it tells from like the comments on Reddit, the site is so horrible that I ended up going somewhere else. That was definitely good news for us, and if one person is writing that, I'm guessing the hundreds more are doing the same thing. And then we had another comment here. I work for Elkjøp, and it's as frustrating for us working at Elkjøp, and it's probably working in the stores, which is our best customers in a way. And this is just two. You can find a lot of these on Reddit. Hopefully, like the last 2 years back or something. Not now, but we have moved from that to this. This is like the core vitals, as you can see it from Vercel dashboard. So this is on desktop scores. We also have the mobile scores. We're not perfect yet, almost, but I think we're doing fairly fine. And we also, if we go on like the official page speed, we do score good on all scores this is for Norway. I think we are doing good on all countries now, except for Finland, where the IMP score might be right above 200 milliseconds. And this sort of matters. Like these scores, you can always trick them if you want to. Some might be hard, but at least they give you some indication of the performance of the application. And just to show some visual of how the application behaved before the rewrite to move to Next.js, and then also how the application is now when we have made some improvements, and also how it was before. I have some small recordings here. So this is how it was when we launched the Next.js application. This is the old one. We were running it side by side with the Next.js application. We should start now, yeah. So this is then we have the Next.js application to write. And it's faster, for sure, but it still takes, you see some lag on the images, etc. And then we have the last one, which is how the application is now. And this is significantly faster, because on January this year, we had a CDN proxy on top of Vercel, which is not ideal, and they don't recommend it. You can have it. It did benefit us for quite some time, because we did want to have a gradual rollout, and then we can have the proxy to route to both applications at the same time. But you can see it has a significant impact on performance. And I think, yeah, it took 33 seconds now to get to the checkout. The old one with Next.js is soon there. And this one here you can see that the button is not even responding. I think the user recorded this actually clicked this button 3 or 4 times, but nothing happens. And that's not how an application should be. So that's what I wanted to improve. And I think we went from, as you can see here, 1 minute, 55 seconds to 33 seconds. And it was not like a speed run by me. I might have done something slightly faster. It was just less weight and have a button that works. So, short about me before we move on. I'm Thomas Jansson. I work for Elkjøp Nordic. Been working there for 5 years. I've been only working on the Ecom part for 2 years or so. I'm a principal software engineer at Elkjøp. And Elkjøp Nordic is, as I said, the largest electronic retailer in the Nordic. We have like more than 10,000 employees. I think it's around 13 maybe. 400 stores. So our store presence is also an important part for us. And we have stores in Norway, Sweden, Denmark, Finland. That's where we have our e-commerce site, but we also have franchise in Faroe Island, Iceland, Greenland, I think. I start to get older, I realize. I actually tried to make this ChatGPT profile picture yesterday, and it made me make me look much younger. And then I realized I am old. And I've been doing coding for quite some time. I started doing like Perl programming, which was also web, I think, at that point in time. Well, actually, we used it for testing. And then I had done some SAP and ABAP coding, and also JavaScript, C#, F#, you name it. And done everything from a lot of infrastructure as code to front-end development as I'm doing now. I like to try to contribute where I think I might have a good impact. I do think you always need to try to challenge status quo, so change is something I really believe in, because otherwise you will sort of stagnate. Since the industry is moving so fast, you have to try something all the time. It might be that you're doing the wrong thing, but then you can at least try something new. So that's in short about me. So, how do you get started with doing a rewrite that we did? As I said, like the new site that we had, the old new site, if you like, it was sort of the first version was finished about 5 years ago when I started working at Elkjøp Nordic. And that was quite a significant investment. At that point, I think they were working on it like 2-3 years. And when I say finished, it was not really finished. We launched it, but it was sort of finished like maybe 2 years ago when we decided to actually move to the new solution. And it takes some, you need to have the right motivation actually to replace something that's that new. Because like when a company like Elkjøp make that kind of investment, they do it because they think it will last for at least 5-10 years or so. And now I said we should replace it because it's not good enough after less than a year almost. So how do you actually drive that kind of change? And as developers, I do think we are good at a lot of things, but we might not be good at talking with business. And that's something we definitely need to improve. So how can we actually make an impact with how we communicate? I think that's very important. And there are different things we can do, and hopefully there were some tips coming here. So the first thing we should do is, in my opinion, talk more about the problem we want to solve, and not as much about the technology. I mean, we love to talk about technology. I can do that all day if I want to. But if you're talking to to the management, or if you talk to a customer and try to talk to them, they couldn't care less. I mean, management and shareholders, they want to know, how can you increase revenue? How can you cut down cost? Like, if you're going to say we're going to have React with something, they don't care. They won't know what's the impact. And when you talk about customers, how will that change, improve the customers? In our specific scenario, I do think we have had a significant impact on revenue. It is quite hard for us to actually measure the impact of the site on revenue because the macroeconomic situation, it goes up and down. We have seen positive numbers the last since we went live, but that doesn't mean it was the solution that drive those numbers. It can still be macroeconomical effects. So when we sold this as an idea, we addressed the cost perspective because we had a team, I don't know, 15 to 20 developers at the time work on the front-end solution. And our point was that we can do it with 3 or 4 and finish in a year or so. And that will also be the operational cost after that. So when you have identify like this is a problem you do want to solve, you also need to quantify it somehow. And this is why I think that the business side is actually getting heard a lot more than us, because they work with the Excel spreadsheet and they quantify everything somehow. I'm not saying they are right in how they quantify things, but they make assumptions, and we need to make assumptions as well. And that's perfectly fine as long as you are clear with that this is an assumption and we are thinking this is how it will play out. Of course, you can have wrong, but the business can also be wrong in their assumptions. But at least you have to do it and put the number on it. So for our perspective, it was we are going to cut down costs this much, and we will have sort of a graph of when we will basically break even compared to today's situation. And it's not like super hard. If you just list down the cost and if that's your address, then you basically see like this is how much we're going to cut down and this much how we cost, and then you see like the breaking point. And then it's a make it clear to make a decision. And this thing I think is very important. And especially if you are a consultant, I think this is even more important. Because as a consultant, you come from the outside, and you need to be sort of included to make a change. And I also think it's even more, if you take our scenario, where we actually replaced all these 15 people who were consultants. So if you don't drive that change, you might actually be replaced by someone who drives that change. So I think it's very important for actually consultants to actually be even more proactive. And that makes it even more important to pair up with someone to get the influence into the organization. And I was like still fairly new, because Elkjøp Nordic, we are 500 people there almost. And I do not have like the large network. I showed some people of what I think we can do. And I also had some also external consultant with me to help build a really, really early proof of concept. But then I also got some interest, if you like, by one other colleague or a great friend of mine as well, who really believe that this is something we can do. And having this first follower is super important. First off, he's your first follower, so someone actually believes you. And he also had like a greater network into the organization than me. And he also complimented me on things I am not as good at, like creating the business case, creating the presentation, etc. And without him, I don't think it will ever happen. Or at least it would take a much longer time. And that was partly because he complimented me and also had a network that was not the same network as I had. So we together created then that's actually the next slide. We started creating this business case, basically a large, not large, like 10, 15 slides of what is it we want to achieve, and also a plan of how we're going to do it. And it's also important to be very focused. When we started out, we said we're going to create a new website, replace the CMS, replace the search, but then we just settled on just do the website. I'm not saying I don't want to do other things, but you have to focus down to actually make it both more realistic and also make it easy to deliver. Because if you can do the first thing, you can also make it easy to get acceptance to maybe do the other things later on, if it makes sense. In addition to just creating the presentation, as I said, we created a super early proof of concept. So we show that we can actually do this. That's where I had my other external consultants helping me out. So we did this basically on the evenings, and at the point of time, we were working on the sort of infrastructure side on the old site. So while we were waiting for the old application to build, which could take like 30, 40 minutes, we had time to spend on this proof of concept. And that took us quite far. So it was pretty fun. So we created this early proof of concept so we can actually show like this is possible. See what we have done in basically 20 hours. And that gives some confidence that we can go with. And also we do not sell this as you typically do in a large enterprise. Like we're going to have these massive projects over 2 years. We said give us 2 months, and it was me and 2 other developers. We saw basically over the summer in 2023. And then we can check in August or September or something, do we want to continue or not? And for us, that's a pretty small investment. So it's hard to say no to that, which was sort of tactical as well. But we then could also show that this is actually doable, and then we could continue afterwards. And it is also okay to fail in that point. And that you shouldn't think about it as a failure. It's more like a learning. If we were fail after the summer, I would be perfectly fine. And we at least learned that, okay, this is not the right way to do. But we failed cheap, and that's I think is a good thing. Yeah, and when we are in discussions with management, whatever, someone will always tell you that the timing is bad, and have anyone been in a situation where timing is good? I don't think so. Like timing would have been good like 5 years ago instead of doing the old solution, but that's hard. And I mean, of course, it can be bad timing, but if the business case is strong enough, I think it's good to start as soon as you can. But of course, someone needs to look at the whole organization, at what else are we doing, etc. But timing is always bad, so that's like a really poor argument, in my opinion. You have to bring out other things you are doing. And I think that sort of concludes like the first part of the presentation. So let's go into the more technical part of why we choose Next.js. How many here are working with Next.js? About 40%. That's good. And front-end developers, that was like 80, wasn't it? I think so. Yeah. You know enough, I think. So why Next.js? When I think about web application, I think about web application as like a spectrum. You have like these pink blogs on one end, which are super static, and then you have like really dynamic applications, think trading, gaming, chat applications, whatever. And when you're picking a solution, it's good to know where you are on that spectrum, as I did. And also, like all tools can most of the time solve everything on that spectrum. Just a matter of like where do they excel in a way. We had Angular before. I would not choose Angular for anything on this spectrum, but if you would choose Angular for anything on this spectrum, I would go for the more dynamic part. But because it is a framework, in my opinion, that was meant to sort of replace desktop applications, quite dynamic interactions, etc. But I think you can do that in many other frameworks as well, and also easier without inheritance. So we choose Next.js mainly because it's React-based, and there's a quite large talent pool when it comes to React, in my opinion. And in a way, it's sort of quite boring choice. It's sort of not the standard now, but I would guess like the majority of new, larger front-end applications are probably using or starting with Next today. If that's a good or bad thing, I don't know. But it was like the existing talent pool we had, new React, and I also think that the future pool will also most likely know React. So it's quite easy choice in my opinion there. I'm not saying like choosing something else like Svelte or something other even more performant is a bad thing. I would love to go down that route, but you need to have like this critical mass who believe in that to do that. I have tried doing that, not with Svelte or Go, but with other things, and it's hard to push those kind of things. You don't have enough people in the company organization actually believe in those technology choices, and I'm really passionate about it. So like, do it if you want to run into the wall fast yourself. That's perfectly fine and learn, but I recommend having more people. So what did we learn after we chose Next? We started off going to Edge, which is something Vercel pushed quite a lot since we were hosting on Vercel. And Edge basically means this. You have the application there running close to the client, so the communication there is very, very, very fast, which sounds really good as long as you don't have like these long arrows to your APIs, which we had. Then it's horrible. So that was like a learning we had back. I don't know why we even think about this before, but that's fine. So like a couple of days before we said we're going to do 100% live, we said, okay, let's skip this Edge thing and go to create a static site instead. And that basically means running on functions, because if you're running on Edge, you can't cache the application either on Vercel, because that's not always dynamic, which sounds really good, because then you can do more personalized stuff, which we do want to do, at least in the future. But then we moved to static, and we managed to finish the migration like 2 hours before we said we're going to do 100% live to the application and start a campaign. And it worked out fine. No stress. Other thing, there was something we really learned in January this year. Network jumps matter. I think this really depends on your overall infrastructure. We had, like I said, another CDN on top of our application, acting as a proxy, and that is fine. It was necessary for us for a long time, but you can see a significant decrease when we went live here. We had like a 40% improvement on the time to first byte. I choose time to first byte because that's really what matters. All the other metrics are sort of dependent on time to first byte. If you have a low time to first byte, you will get faster images, faster contentful paint, faster interactions when you're talking with your server. So this is sort of the core Web Vital, if you ask me. So if you can, remove as many network layers as you can, but still try to keep it safe. And here you see like the graph over time, and the bar at top shows that we actually managed to do something. Now we're going to Next.js. How Next.js works is you have something called layouts and pages. Next.js is very opinionated. So if you can't buy into those opinions that Next.js has, choose something else. I mean, there are a lot of good options out there. So don't torture yourself with something you don't like. I'm perfectly fine with this because I don't like reinventing the wheel. So if someone says to me, oh, here's a structure you could follow, I'm perfectly fine. So I buy into this. I'm not sure how much, like, of course, we're experimenting with things, but at least it gives us some kind of direction of, like, if you want to have some routing, you do it with folders. Okay, and we don't need to think about that. So a short demo of how that works. So for me, I said, like, this is more than for how you organize your application, but you do get some other benefits, as you will see in this short demo here. You see the flashing thing when I reload the screen. This is because of how the application is composed. So it only renders the parts that are necessary when you're navigating. So when I go to marketing, the whole layout here is still, an outer layout is still fixed, but it reloads the page. And I go to orders, it only reloads that. And now I have a listed layout inside the layout, which I will show, and only that part is reloading. So it gives you sort of visual stability as well, and also a nice organization. And it is quite simple. So here I have my layout demo. I have the outer layout, the fading component, that's a green flashy thingy. And then I have the children, which I then can compose with my outer route, which is orders and marketing. And this one has another inner layout, which has its children, which are then sort of injected there. So this is quite easy to sort of make this, to compose an application together using this. React Server Components, that's also fun. Was sort of a new thing that came with Next.js 13, was the first one implementing it. It's not a Next.js thing, it is a React thing, but Next.js was the one pushing it first, I think, and a lot has influenced how it works. If you want to build a complete static application in Next.js, that's what you get as default. Everything is a React Server component. So then you get everything server rendered as long as you don't say, I want to have this client side. And you can do that with a directive called useClient that you put on top of a file. And if you do that on a component, you get a client component, which I mark as green. And that's perfectly fine. And still, like, a client component is also first rendered on the server, which is good to know. So you get all the good stuff with like a sort of fast initial view, but then the client takes over. If you do it higher up in the tree, all the component that client component is initializing will also be a client component, which is really important to know because that will impact your bundle size. So in this case, the client bundle will, of course, include the Next.js sort of runtime, if you like, on the client, but then you have the green and the blue box will be in the bundle. There are ways to work around this. Instead of having the client instantiating the component, you can have like a server component, putting those in as children to the client component, and then it will actually not be a client component. And also have a short demo showing this. So I have a really sort of schizophrenic component called server client, which is green when it is on the server, and it's red when it is on the client. So we had the first page, which is a whole green box. In there, I have a server client, which is the green box to the right, because it still runs on the server. Then I have a client component, which is the one below here. This is a client component, and this would also make this box red. But here you see that I sort of injecting or putting children as a server client. So these two components here are rendered on the server and not on the client, which is a really good thing you should leverage as much as possible if you're using Next.js. But then I have this other server client component. Since this is instantiated from the client, it is also marked as a client component. Next part, internationalization, or I call this a middleware demo. The middleware is, I think, one of the really great features I have in Next.js. It's not a new concept by any means. We use it to actually decide, like, all the application we have is one application serving all countries. And we do that by leveraging middleware. So we're selecting which host name are you coming from, and depending on that host name, we are rendering a different part of the application, basically. So the route you see in the browser is not the same as the necessary application route. It doesn't have to. That's something you can change in the middleware. And the way we do it here with like is something you can do like this. This is sort of the concept here is the same we have. We have slightly more complex, which I'll come back to in the next slide. But here I have an application where I can say hey in a lot of different languages. But the cool thing here that you don't see is it's always the same URL, no matter what I have, but it's always a static response, a cached response I get back. So whenever I click one of these links, which links to /no/sc, I actually check the code there, or now you try to go to the Swedish version, then I will set a cookie for you telling that you are from Sweden, and then redirect the route, and it will serve you the static context. So if the cookie exists, then we will serve you the site for that language. And that way I can have a cached response that's sort of individually per user. And this is a really powerful thing, because you can use this for personalized content, for example, and create a cached experience. For us, working in retail, we could have like a cookie with your persona. And if you are a gamer, we can give you a gamer homepage that is cached and as fast as our original landing page. So it's a super powerful feature that I really recommend looking into. The next part is one thing that Mikael mentioned in his talk, feature toggling. I think this is, I haven't used this a lot before, but now we use it for everything, basically. And this is something that really can make you move much faster when it comes to development. Because if you have feature toggling in place, you can push things to production whenever you like, basically. As long as it's behind a toggle, it won't reach the customers, and that's perfectly fine. So we try to work very small, also, like Mika mentioned, because that helps us reduce the cycle time, and also put things behind a toggle, so allow our internal users to try things out before it reaches our customers. And when using Vercel, we actually get the feature toggles included in the toolbar. So I can show my feature light theme, for example, and now I have a slides light theme. And this is still sort of, I'm checking my toggles now in middleware, so I get still a static and cached experience with the toggles enabled. And that is also something I do recommend. If you're going to create a performant application, you should try to resolve the toggles that you need to render the application should be resolved in the middleware, and then you can actually use it in the applications without getting a dynamic page. And you need to have a static page to be able to cache it. I like the black better, so let's remove this. I don't think, like, even if you don't run on Vercel, you can create a UI like that can be simply create yourself. It shouldn't be too hard. I do recommend maybe to encrypt the flags, etc., so not anyone can go and change them. That's something we get out of the box, I think. And I also recommend not implementing the flags yourself. We did that because there was not a framework for it. I will use the flags SDK that Mika had in his slides, and also look at what's called pre-compute flags that would give you the static experience. Server actions is also another feature that came in next, I think it was 14, maybe 13, which, I mean, was a lot of fuss when this came out, I think, unnecessary, if you ask me. For all this is just an abstraction on top of some API, so you don't have to write all that boilerplate code yourself. It's not like super magical. I think it's nice. We're not using it a lot, but we're using it some. But if you can use it, but there are, of course, disadvantages because you can't get everything as a post, so caching becomes awkward, for example. So I've tried that. Don't use it. Forget. But it's really convenient when it works and fits your needs. So definitely recommend using it. And a short demo of that as well. I have my really black theme here that you can see. So if I don't write anything, you can see I have. This actual validation happening on the server is still fast, but if I do a name, it takes even longer time because now it's actually simulate a database thingy. And you can also attach it, this is a form, but you can also attach it directly to a button. So this is something actually that runs on the server and then triggers up the alert on the client. And the way you have server actions is also quite straightforward. I have two different components here, a form demo and client demo, which is here. And then I have my submit. You pass it in as an action to your form. And this submit then calls this handle form action. And the form action, I like to put them in a dedicated file. You don't have to do it, but it makes things cleaner if you ask me. And then by using have this use server on top, I'm telling like this is sort of a boundary. This thing should live on the server. And then Next.js will create all that boilerplate that make that happen for you. So you have the handle form action and the button clicked action. So it was running locally, you would actually see this log statement being printed on the server and not on the client. And for the client demo, you just add it as basically a regular on-click function. So caching is hard, especially if you're doing Next.js, because there have been some confusion over the years. I think they had some good intentions with the Next 13, where they said, okay, now everything in Fetch will be cached by default. I mean, intentions were good, but they also messed up the whole API for it, because that was not how the API worked. So if you're going to do something with an API, please don't change how it works. So it made it somewhat confusing. How do you opt out, etc. And you explicitly need to opt out, which made things very confusing. I'm not going to go into a lot of detail here, but if you are going to use caching, I recommend trying to use the revalidate functions and not time-based. It might be harder to set up, but it's much more efficient if you ask me. Because if you have time-based revalidation on things, I mean, it's perfectly fine if you can have time-based on the whole page. But as soon as you start breaking it down on all the different functions, and all those functions might be used in multiple different pages, it gets complicated and confusing on which time is going to be used. If you have like 30 minutes here and then 10 minutes on another function, and they are used, like, I don't even know how it works. I think it's the shortest time that should always win or something like that, but it's hard to verify. But we have, if it's set up to be relation based on events, it's much easier. You can just have an endpoint that you call, like when a CMS page change or a product change, you can just call this endpoint with a specific tag, and it clears the cache for that data. When we talk about caching, I really look forward to the future, actually, with Next.js. because they are coming with something called partial pre-rendering and streaming. I hope it will be announced or released this year. I think partial pre-rendering has been sort of in a canary release for 1.5 years or so, but they have redone everything about how caching works. You will now start using a use cache directive inside function, and it will be also much. The scope will be quite different because now you're limited when it comes to caching to when you set in the cache keys or tags. That's what you can use to reevaluate the tags cache. They have to be set up front, which might make it hard when you have sort of recursive things. If you ask for a page from a CMS, for example, you might get some response back saying, oh, you need to also get this content over here based on this ID. But you can't actually set the cache tag for that ID, but you can if you can that with a new API for caching in XJS. And then they also have streaming, which allows you, or streaming and partial pre-rendering, which allows you to return a really fast initial response and then stream in the dynamic bits as they are finished. And I have a short demo how that can actually look like. So here you see both things are sort of loading because it was the first time I went to this page. If I do a refresh now, only the second box is loading. So on the first request, both these boxes or HTML in these boxes just had sort of a marker thing in the HTML. The second time, it actually figured out that, okay, this second box can actually be static. So it has sort of injected that in the HTML. So my now cache response is actually containing the whole layout plus this box, which is really good from a performance perspective. And it's a really good feature if you're working for e-commerce, where we have like a lot of product lists with filters, etc. Because we can then deliver sort of the static shell with everything, and then we can stream in the products and the filters when they are finished for a really fast experience. Now we sort of can do that, but it requires a lot more work. And if I do a revalidate here, just using a tag again, I will get 2 loading boxes, and then they will stream when they are finished. So as long as they are revalidating, you will still get a fast response, but you will only get the skeleton until it's resolved. So lastly, some Vercel features that we're using. Deployments. Mikael mentioned this in his talk about preview deploys. This is something you get for free from Vercel. So every time you push to Vercel, you get a new deployment. And that's very good. You should also leverage another feature called, I should change around this, I think, environments. Because then you can pick one of your commits and say, okay, I want to deploy this to this environment. So you can have like a test preview and test, and you will actually deploy your branch with the production configuration. And deploying with production configuration doesn't mean it is the production version, because you still need to assign the domains. And that's something you should try to separate, or at least we do. So deployments and environments are really 2 key things. And of course, the speed insight is another thing that we look at a lot, especially since performance was one of the important things for us. So we have looked at this a lot. And the last thing, which you can't see here, is this small little widget where we have like the toolbars with both the feature toggles, which we use both developers, but also everyone in the organization that do the testing on the site are using the feature toggles. They also have things to look at layout shift and accessibility, etc. All those things content free. You can also comment on the page. We did that in the beginning, but we stopped doing it because there were too many comments that things were wrong and not like the old site. So we got overflooded, basically. So now we use Jira for everything, which is fine. It is. To summarize, change is hard, but possible. But it should take time, and you will get some resistance for sure. So you need to like the pain to do it. But I think it's fun and rewarding when it works. And to create a performance application, technology is super important, but you need to have the people and passion to actually do it. And as I mentioned, the spectrum part is super important. Know where your application is, and also when you're working on the application, a specific feature, know what that feature is. Is that a dynamic feature, static feature? How should it work? Next.js for me lets me focus on application. I don't need to think about build pipelines, etc. That's all taken care of. I haven't touched Webpack. I didn't know Webpack before Next.js. I don't know now either, so I'm quite happy with that. It just works. And I think Vercel sort of solves the same thing for as Next.js, but they do it on the infrastructure side. I'm perfectly fine doing infrastructure work. Like I've been working with infrastructure as code for many years, but if I don't have to, that's also very good as I see it. So Vercel solves that problem for me. We can just put the code together with Next.js, ship it to Vercel, and Vercel hosts application for us. And I think that's everything. Thank you.
Hello, and welcome to my talk, 10 Reasons Your Application Isn't Accessible and What You Can Do About It. My name is Elise Christiansen, and I'm a front-end developer in Variant. And in my 8 years as a developer, I've seen countless of websites being launched without being properly universally designed. And that's why I've made this list with my very clickbaity title, and I'm very sorry for that. And since this is just a short talk, I will not go hard in onto how to technically solve all these issues. I'm just trying to get you aware of them and give you a little nudge on how to solve them in a very superficial manner. I will begin with some of the more technical issues and then later on move on to some of the more structural issues. And I have to say before I continue that creating a website that is universally designed is also very good for business because it helps the SEO score and you have a lot more customer range than if you don't have an accessible website. And I have to talk a little bit about the law, even though it's a little bit boring. The law is accessibility on web has been legally required in Norway for years to ensure that all websites and web apps are accessible for everyone. A website that isn't accessible is just as bad as a building without a wheelchair ramp. The law is called a Regulation on Universal Design of Information and Communication Technology, and this regulation was established under the authority of the 2008 Anti-Discrimination and Accessibility Act, which aims to prevent discrimination based on disabilities. But we are not in Norway now, so I have to talk a little bit about the regulations in the EU. The European Accessibility Act is a directive that aims to improve the functioning of the internal market for accessible products and services by removing barriers created by divergent rules in member states. And if you don't trust me that it is actually legally required, you can scan this QR code to read about the law on the EU pages. 15 to 25% of the population has some form of disability. And that's why it's so important to not exclude this many people from the digital society. It can be that one has broken a wrist, so he temporarily can't use a mouse on a computer, or sight that is slowly fading away. So you need to focus on accessibility, and it's so important. So I will help you with that. And now on to something a little bit more lighthearted and fun. My cats. This is my Bengal cats, Luna and Venus. And these cats will follow along with my presentation to give those who are kind of like me, who struggle a little bit with concentration, something to focus on during my presentation. Studies show that including pictures of cats can help maintain people's attention for longer. And the cat pictures are rarely relevant to the content of my slides, but who doesn't love a good cat picture? Now, let's begin with the list. And this is the technical issues. Issue number 1, insufficient alternative text for images and graphics. A person with blindness or deafness needs to be able to get the same information as everyone else. To detect some of these problems, you can use a scanner. A scanner will help you with a lot of these technical issues, but not all of them. And I'm trying not to repeat myself too much, so I will just give you one recommendation for an accessibility scanner I use a lot, and that's Pally. Pally is an open source accessibility testing tool that helps developers and designers identify and fix accessibility issues on websites and applications. A scanner will be able to tell you if an image or video lack any text alternative at all. However, a scanner might not be able to tell you if the image text gives enough context for the multimedia. And I will give you an example with my great Photoshop skills. An image of a cat that is trying to catch a bird might have the descriptive text, a cat and a bird. And a scanner will tell you that this is good enough because it has a text alternative. And the text also tells you what's in this image. But it doesn't tell you anything about what this image is trying to tell you in a context. For an article about birds that are going extinct, the image text might be bird being hunted by a cat. But for an article about a cat's behavior, the image text might be cat hunting a bird for fun. So make sure that all multimedia elements and images not only have text alternatives, but the text also gives away all the relevant information for the context the multimedia is in. Issue number 2, failure to use available text alternatives for videos and audio files. The necessary types of text alternatives must be carefully considered. And there are various kinds of text alternatives you can include. We have captions. Videos with sound must have captions so that people with hearing impairments can follow along. And make sure that the captions are readable by a machine and not burned into the video, because a screen reader or other assistive devices will not be able to read if the captions isn't implemented properly. We have transcriptions. Audio files and videos must have text transcriptions. And we have audio descriptions. Videos with important visual elements must include audio descriptions for visually impaired users. Issue number 3, missing a bad link text. A common mistake is missing or simply just bad link text. A web app or website is mostly full of links that are either taking you to a new site or taking you to another place on the same site. But we as developers have a tendency to put insufficient text like just read more or icons as link text. And how is a person with blindness supposed to know what more means without having any context? So use descriptive link text for all links. For example, read more about bees for an article about bees. And use ARIA labels for icons. For example, go to homepage wrapped around a house icon. But this is how you meet the WCAG standard. It's sufficient to just have an ARIA label around an icon. But we can make this even more accessible for other people by adding a word as well. If you add a word or two about where the link is taking you, this will actually be visible for everyone and not only those with the screen reader. You can help out a lot of people who don't have the same associations to a house as you. Maybe old Martha thinks that the house means that it's linked to go buy houses, or that it symbolizes leave the house, like a link that takes you out of the site altogether. Or maybe a store or something. So I think that LinkedIn is a great example of how you can do this. I have Facebook on top of LinkedIn and LinkedIn right below, and they have used words for every icon and every link in their menu, so that everyone can know where all the icons are taking them. So yeah, I think it's better, and it makes the user experience way better. Even though maybe you think the Facebook one looks better, but user experience is key, so yeah. Great reminder. Issue number 4, inadequate contrast between text and background, which can make it difficult for people with visual impairments to read, and solving this also makes it better for everyone to read your content. You can get help from scanners, and you can also use the browser's inspect tool. The inspect tool in the browser is a very useful tool. Most browsers let you hover over an element and see the contrast ratio right then and there. In my 2 examples, I wish I could point and click, but yeah. If you see right below accessibility here, you have a contrast number, and the higher the number, the better the contrast. It even has this checkmark symbol and this warning symbol and a name. One is named good contrast ratio, and the other is named bad contrast ratio. So just hover over everything you are unsure of has good enough contrast, and this will help you a lot. But remember, text on images and gradients, it's not that easily caught with just computer tools. So you have to manually check all the colors in the background of an image up against the text color you have put on top of it. Issue number 5, insufficient lack of content structuring with proper use of headings and lists. For assistive technologies to work optimally, the web app needs to be written with the correct tags, especially the right use of heading tags. The different numbers are for semantic and not for styling, as so many people use them for. It's important to begin building the web app with the correct tags from the very beginning, because rewriting it will take so much time. My best tip here is that every time you want to use another div, just try to think about another tag to use. HTML is such a rich language. Use nav tags for navigations and use p tags for paragraphs. It has so many different options. Issue number 6, missing keyboard navigation and incorrect focus order, hindering people who rely on a keyboard to navigate your page, people who can't use mouse on a computer. For one easy way to check your page yourself is just to use your own keyboard. Just tab through everything and check if everything is reachable by a keyboard and clickable by key press. A common mistake is to make clickable elements only reachable by mouse and only clickable by mouse click, so make sure you have used the correct HTML tag, and you can use tab index in need. But try to avoid using tab index, because it should be an HTML tag that already solves your issue. And now we are moving on to some of the more structural issues that can't be fixed with just a scanner. We have inadequate testing with accessibility tools and user testing with individuals with various disabilities. It's difficult to develop for challenges you don't have yourself. When you develop something, you tend to take your own experience of the product as a starting point. And you assume that users of screen readers and assisted devices are experts themselves. But they are not. David, a 75-year-old who just started to go blind but has never worked on a computer in his life, doesn't have any better prerequisites than you to know how to navigate a screen reader. You are the expert. You know your app. And if you can't use a screen reader on your own app, how is David supposed to do it? So set up good testing routines. User testing is extremely important. User test on people with disabilities and make sure that testing with disability devices is part of the estimate. But estimations takes us right to our next issue, lack of accessibility awareness during the design and the development process. Developers tend to forget about accessibility when they estimate. And when the development has started, one may feel that it isn't enough time to incorporate it. Take responsibility and focus on accessibility already in the planning process. Make sure every participant knows how important accessibility is. The designer, the developer, the customer, the editor who are going to publish content on the web app. Everyone needs to be on board. However, the fact that everyone wants to focus on it doesn't necessarily mean that everyone knows how to. And that takes us right to our next issue, inadequate training and awareness among developers and designers about the importance of universal design and how to achieve it. Encourage developers and designers to take courses. There are plenty of easily accessible courses out there that can be done in just a few hours of the workday. They are definitely worth the investment. And to our last issue, economics. People believe it's much more expensive than it is to develop for accessibility. So they fall into the trap of using accessibility overlays instead of coding the website universally accessible from scratch. Design for simpler and cheaper websites. Keep the routines and guidelines in mind and scale down functionality and needs. Don't compromise on accessibility. A black and a white website in Times New Roman without any design at all, with all elements just listed one after the other, is way better than a website that isn't universally designed, because it doesn't exclude anyone from using it. And that was all my issues. You can scan this QR code to read the whole thing if you didn't manage to take notes or if you want to revisit all these issues. And yeah, some sources, and you can add me on LinkedIn if you want to. Thank you.
Hello. Now we are going to talk about why fetch makes you wait twice. And the two awaits I'm talking about are the first one, when you actually make the request and you get a response. And the second one is when you say, I want to make this a JavaScript object and read it as JSON. Who here has written these two lines of code before? That's basically everyone. So yeah, that was the first one and the second one. And we already have the response, right? Why do we need to do the second one? We have the response, right? Is it just that parsing JSON is super slow? And the answer to that is no. You can do that synchronously. And it's not specific to JSON either, because you have to do this if you want text, and even if you want raw binary data. So what is it that fetch actually returns? And the answer to that is it returns a response object. And the response object has methods that you can use to read the body. Those are the ones we saw before. And what do we get if we just log the response object? You get something that looks like this. I've prettified it a little bit because JavaScript's console log is weird. But it says that the request was successful. You got a 200 response. Here are the headers you had. This is the URL you called. You were not redirected. And then it says the body is a readable stream. And what does that mean? So what is a stream in JavaScript? Basically, you can picture it as a water hose or a stream of water where data is water and you're putting it in on the one end and it comes out on the other. So you have you can put water into it and it comes out. It may also be easier to think of this as actually putting boxes of data on a conveyor belt and it goes through and you can consume them. It's important to note that once you take a box out of a stream, it's been used. That's why if you call JSON twice on a response, it says body has already been used. There's an error. What do we actually send back and forth when we call fetch? So when we make the first HTTP request, what we're sending is just a text file encoded as binary that says get the route, and we want JSON in return. There's nothing magic about this. The only thing you're sending to the server is this text file, and some other headers probably. But what you get in response is also not magic. You only get a text file. And it first says, here are the headers, like success, and we're sending you JSON. We're sending you this much JSON. And then you get all of the JSON as data. So the important bit here is that fetch will return as soon as the headers have arrived, while the actual content and the JSON could still be on its way. Yes. And one thing that we tend to forget these days is that the internet actually takes time to do things. You have to send data over the wire. It doesn't arrive all at once. Once you make a request, it might seem that way because websites are super fast these days. You click enter on your address bar and just a website shows up. But there is it's being sent bit by bit over the wire. So what we're going to do is we're going to simulate a super slow connection. And I am going to make an Express web server. And once you call it, I'm going to immediately say, it's OK, you're getting JSON. And then I'm going to open up a JSON file. And I'm going to read it as a stream from the server. And when the stream is ready, we're going to read 1 byte. And then I'm going to write that to the response that I'm sending back to the user. And when we're done, we're going to close the stream and say we are finished. And we're going to read 1 byte and do that every 5 milliseconds, which is a speed of 0.2 kilobytes per second. So dial-up in the 1970s was about 50% faster than this. But we are reading a relatively small file. If you had a bundle size of 200 kilobytes, you would probably be reasonably happy, right? And 1080p video today is 3.5 times this file every second. So we are sending a lot of data. So yeah, now we're just going to, these slides are a website, by the way, so now we're doing an actual fetch call. We are running JavaScript. So we're going to run those 2 lines. First, get the response, then try to get the data, and we're going to see what happens. Yeah. Okay, that's not super fun, right? Some of you may have done a little bit of math and realized that this is going to take 17 minutes to finish. I don't have that much time left in my presentation, so we are going to try a better way, and that is by streaming it. And since the body of the response is readable stream, and we get the response right away, then we can consume the data from the stream directly. And now we're going to run these lines, which is first, say, get the response. Then we're going to make a text decoder, because when we read from the stream, we get binary data, and we have to turn that into text. And then we are going to say, every time we get a byte of data from the stream, you're going to decode it as text, and you're going to attach it to the string that we already have. And that looks like this. So this is binary data being streamed from the server onto this laptop, and we are decoding it and showing it to the user. So both of these methods will take 17.5 minutes to finish, but at least for the last one, you are getting content that you can show to the user. And as Thomas talked about, this is what something Next is starting to do now, where you can stream data to the user on the client components. So streaming is pretty cool. But should you stream everything? No, I don't think so. Regular way is fine for most things, like normal web pages loading. yes, normal web pages and fetching small files, stuff like that. But you should consider streaming if you have extra large payloads, such as movies. Imagine if you went to Netflix to watch Oppenheimer and you have to download the entire 3-hour movie before you could hit play. That wouldn't be very fun. And also, if you have small speeds, if you know that your users are going to be in remote locations and it's critical that every bit of data is used, then do streaming. And that's why I have to wait twice. Thank you very much.
Yes, moving on. Junior revolution. So anyone here been a junior developer? And are anyone here responsible for buying consultants? At least one. This is also for you. Okay, this is me. I work in Vaillant Bergen. And what we're seeing in the market, and what we have seen over the last couple of years, is that we get this obsession with seniority. Traditionally, consultants have been experts and have come in to enlighten our customers. And the quality of these experts tends to be measured very frequently by the number of years of experience that they have. And especially when you have a competition in the public sector, it's really easy to use number of years of experience as a criteria because you can measure it. It's 100% objective. But what happens is we end up in this paradox where everyone wants senior developers, but we don't know where they come from. So anyway, we have a goal of recruiting and employing juniors. And we have been actually pretty successful in Vaillant with doing that, both developers and designers. And we have been able to find talent who fit into our organization and are productive. And we also discovered that having juniors here, it adds something to the company. It brings updated knowledge straight from universities where sort of knowledge originates from. And it brings young minds with very little experience, so they don't see all the limits that us who have been working for a few years have built for ourselves. And often young people coming out of school have a can-do attitude, want to work and get things done, which is really good. But then we get this paradox where it's easy to perceive that how many years of experience you have is a measure of how much value you're able to create. Which, if you extrapolate it, means me, I have about 24 years of work experience, so I should create a lot more value than probably most people in here, which my experience tells me is not true. I know that Even some people here who've been working half year, 1 year, 2 years, know things that I don't. And by working together, we will create more value than I will alone. So the problem is getting jobs for junior consultants and convincing our customers that juniors will be able to create value in the team. Because if customers only want seniors, where do we get the seniors from? We can't go exactly and recruit them from our customers. So it becomes non-sustainable in the long run. So there is this perception that hiring junior consultants is risky, which is, in my mind, kind of a myth. And it becomes a myth because consulting companies only want to hire people to customers for a lot of money and pay them very little money so that a lot of money stays within the consulting company. However, what we should remember is instead of hiring in-house juniors, if you hire a consultant, you get someone with who gets 2 separate work experiences at one time. They start working in a consulting company where they get experience from seniors in that company, and they also start working at a customer site where they get experience with how the customer works. So actually they accumulate different experiences simultaneously, which means that they get to adapt more quickly to different environments and learn quicker and actually become more knowledgeable than someone who just sees one work environment. And also, there is a myth that junior consultants are expensive, which is sort of easily measurable because you get a bill every month, you see how much they cost. If you hire someone in-house, you also pay them salary every month. But then on top of that, there is a lot of other things like pension, insurances, equipment. They might become sick and be out of work for a few days. And all those costs are more difficult to see. They become hidden. And finally, by using consultants, you become more flexible, which has a value. You can scale up when there's lots to do, and you can scale down when there's less to do, which is a value in its own for organizations that do projects. And a good thing to explore junior consultants is by using teams. Seniors and juniors together might get a lot more done, perhaps, than 2 seniors together. 2 seniors together will frequently get into discussions, big thoughts, see lots of limitations that they have experienced in previous projects, whereas the senior and junior together might actually get up to speed quicker because the junior wants to go do things and the senior realizes, okay, I can't just focus on all the limits, I have to go and do things and keep up with this guy. So by teaming up people with different levels of experience, you actually reduce the total risk compared to a completely homogeneous team. So the question becomes, where do the seniors come from? And we have to think in the long term, not just the short term. Of course, the easy thing for a consultant company would be to hire seniors from our potential customers and then try to sell them back as consultants. But this isn't viable in the long term. As a professional community, we have a responsibility for making sure that juniors come out of university and into the work environment and have a good experience where you get to learn how to work and how to create value for the customers. So we have to stop being short-sighted and think in the long term, what would be the best. So how do we work to get this done? Well, it is fairly easy. We have to start thinking that years of experience doesn't equal quality. And it certainly doesn't equal the value you can create, which is the important thing for customers who hire consultants. We need to start thinking about consultants as teams, not as individuals. Even if a customer hires just a single consultant from a company, that consultant has access to the total resources of the consultant company, can ask for help, post a message on Slack, and within an hour have 20 replies with suggestions for how to do something. This is not something you can easily get if you don't have a company backing you. And finally, we need to start measuring results and not just years of experience, see what people can produce. So if a profession has no juniors, it will eventually go away. We know that the customer wants value, so our responsibility is to show the customers that they get value. We believe with juniors, we will be able to produce that value. Thank you.
Awesome. Okay, so hi there. I'm Christian, developer working in Variant as well as a lot of others here. I'm going to talk about testing, and I changed the title of my talk last evening, which was a huge mistake because the video intro didn't have time to change, obviously. I didn't tell anyone, so that's a good idea. I'm going to be talking about testing, the general approach, maybe mindset around it, but also tools and patterns and everything. And I'm also going to, like, a huge principle I'm going to go back to in my talk all the time is that tests might actually impact your solution and code base and how you work in ways you do not necessarily imagine at first. And there'll be code slides, no IDE here today, but it'll be in C#, just be forewarned. But I think the principles here will stay true no matter language or framework. All right. But first I have to get you to care about the subject. And I'm sure a lot of you didn't wake up this morning and think, do I need tests in my solution? But this is a fundamental question in my mind. It sort of underpins the premise of my talk. Because writing tests takes time away from doing stuff you might rather want to do when working on solutions. That is writing code that actually does stuff instead of just verifying it. And I've written a lot of tests in my career, and I have to admit I don't really enjoy it at all. I sort of compare it to jogging in some sense, which I do not enjoy either. I hate the act of jogging. I hate being in the act of jogging. It feels really good to have finished a jog. That part is great. And of course, I enjoy the long-term health benefits of actually taking care of myself. And I think testing is sort of like that, in some sense. It is sort of like an investment in the long-term health of your solution. So that is what testing is. But like with exercise, I guess, we humans tend to have sort of a maximalist mindset in some sense. At New Year's Eve, you probably tell yourself that this year I'm going to run 3 times a week and, I don't know, only eat broccoli for breakfast or something like that. And then you do that for a couple of days, maybe some hours, and then you just go back to the old habits of doing exactly what you used to do. At least that's how I work. And thinking about that, I often go back to this quote by Guillermo Rauch. He is the CEO and founder of Vercel, the guys behind Next, which we heard a lot about today. And the quote is, write tests, not too many, mostly integration. And I think, like with exercise, and this is getting to be a tired analogy, so I'll drop it soon, but like with exercise, the data shows even a little bit is infinitely better than none at all in terms of health. So I think if you have just one integration test, for example, if you're building a website or API or something, and all that one test does is check in a browser or anything like that to see if anything rendered at all, that is the most important test you write in the lifetime of your solution. Because how many occurrences of downtimes or just general derps wouldn't be avoided if we on each commit just check, is anything there at all? And I work with solutions that sort of run contrary to this, solutions with hundreds, even up to 1,000 tests. And I'm not necessarily saying that more is better. I sort of want to say the opposite in some ways. But I am saying tests have saved my butt more times than I can count. So that is the general principle around tests. But what we often forget about tests, even though we don't really enjoy doing them, and only if we have to, if we do them, they do impact our solution in ways we might not necessarily think of at first. So this is a visualization I grabbed from codecm.com. Bottom left corner is the link. And the guy behind that is a guy named Adam Thornhill. And I'm not sure if I have any Swedes in the audience, but he is a Swedish guy from Malmö who does a lot of cool work, I think at least. He does a lot of work in analyzing complexity of code and change coupling and stuff, which might sound boring, but you get awesome graphs like this out of it. And what this shows is it's a visualization of the React code base, the React framework code base by Facebook, the official one. And it's showing a hotspot analysis of files in that code base. So basically what it's showing is the larger the circle and the redder it is, the more often changes happens in that file in the lifetime of sort of the solution, from analyzing Git and stuff like that. And what you can do with this visualization as well, you can hover over the different files, and the yellow lines point towards other files that normally changes along with the file that you're hovering over. And the blue circle sort of is modules, packages, which those files are in. And if you take this example, for example, here I'm hovering over React fiber hooks. And if we zoom in here, I was at a talk several years ago now, I think by Adam Tornil, the guy behind this. And he talked a lot about which types of files normally changes together. So I'm hovering over React fiber hooks, and you see 5 other files being pointed to with the yellow lines. And of those 5 files, 3 of them are test code files. And this pattern will show up again and again if you look at different files in this solution, but this is a unique pattern to the React framework code base. Very many professional code bases out there has this pattern. And the pattern is, in essence, that test code tends to become sort of viral in your solution, in terms of changes, that is. And you may notice as well now, as I said, the files being impacted is not necessarily the same files that are inside the module as the file being changed. So not only are they viral, but the changes and the sort of coupling spans across different parts of your system, which I think is kind of interesting. And this is not necessarily something you think about from day to day when you do your work, because nobody will ask you, normally at least, to do some sort of change in your testing code. Like product owners won't open a ticket, please change this test. They will normally ask for big new features or more likely a button, I guess, in some, that's what they usually ask for. And that is sort of the point of my talk as well. Testing is absolutely something you should do. It has outside benefits in terms of how little it requires. But at the same time, test code becomes viral in your solution. And this is something you have to think long and hard about when you architect your test code, which is why I recommend how you look at how you split up your test code, what patterns you follow, and even what you test. That becomes increasingly important. So this is me quoting myself, I guess, but I like this principle. If you write test code, you should architect it as if it is code running in production. Because in the long term, you'll sort of save yourself a lot of work that will become invisible to the people who ask you for new buttons. That's my pitch for why you should care at all. And so I've talked about the why. Now I'm going to talk about sort of the what. And we'll have many code slides coming here. Again, C# code. And I'm going to introduce 3 different files or types here, which I'm going to refer back to all the time. And use to sort of show the different patterns and exemplify the different ways of thinking about testing that I think you should do. So to begin with, we have the dependency, a repository. So basically what this is in C# is a contract. An interface is a contract. It tells you something about how something else should look, how the actual implementation of the interface should look. It has no running code or behavior in that sense. And this is what I call the iUser repository. A repository may have a database behind it or some other backing story. You don't really know. That's the sort of point of the repository, or at least this contract. And this is the thing we're going to sort of be changing during my talk to show the different ways you could test something else, which is this. It is the account service, and here you actually see real behavior. This is what you would call in testing the system under test. And I know this is naive and simplistic, that's sort of the point, so it doesn't take up several slides to show it. But this is the thing that uses the repository to do its work. So this has behavior. And it exposes two things basically, the login and the register method. The register method uses the repository to add the user by email and password. And the logging basically gets the user and checks, is the password the same? If so, you get the user back and you're logged in. This isn't real code, it's just to exemplify the different ways of testing. And last is the test class. It has one method, or one test case, or fact, as you can also call it. Basically, it just checks. With the account service, after I've registered the user, can I log in with it? If I got a null back, then it didn't work, the test is red. So the thing we're going to do here is just to test, is the account service behaving correctly? And we're going to explore the different ways of doing that during this talk. But as you may notice, I'm not actually sending in a dependency here, I'm just sending in a null. And that is the thing we're going to have to fix. And to do that, I have to talk about test doubles. There is a lot of theory in this talk, obviously. I'm noticing now while I'm actually running through it. Okay, so test double, a double here is not the same as the data type double. It's not a number type. It is something you build in order to replace dependencies in your solution. And the Wikipedia definition here is that a test double is used to satisfy a dependency so that the test code need not depend on production code. So in other words, the repository is sort of the thing we're going to replace with the test double. And while this does not exactly contradict my previous code, it does sort of run in conflict with it. So that's also something I want to explore during this talk, because it sort of impacts the mindset you have when you test and when you write test code. But to get back to test doubles, there are several categories, but the main three ones that I want to focus on here is stubs, mocks, and fakes. And we developers, we tend to use this in sort of daily speech. We tend to use them interchangeably in some ways. Like you fake the repository, you mock the service or whatever, you know? But in sort of testing theory, they mean explicit things. And they're sort of going to, my reason for picking these three is they're sort of going to conceptually build upon each other in level of complexity, sort of. So stubs here is the easiest one. Its definition is stubs are implementations that return static values. Short and sweet. And I mean, the implementation as well is short and sweet as well. So I've taken the repository contract here, and I've implemented a stub. So now we have a class. But the thing here is that this has no dynamic behavior. It's just a static sort of implementation that you could argue that the email and the new GUID gives it sort of dynamic behavior, but for all intents and purposes, this is a thing that really does nothing. It does the bare bones necessary to be able to compile the code. So you get a user object back with get user by email, and add user, again, does absolutely nothing. And the way you would sort of use it then in the test code is like this. So you just construct it, and you send it into the account service. And the benefit of stubs, to give it some sort of positive upsides, is that you can reuse the same implementation across test cases if you want to. But the downside is they're so specific and static that they have no real behavior. You're just assuming the way they're going to be used when writing the test code. And so the only reason this works here is that when I log in, I use the same password as in the previous slide, setting it statically to password. That is the only reason it works. So if I, for some other test case, wants to try another password, this wouldn't work. But it does impart real behavior on the account service, because that is the thing actually checking the password. So here we are very specifically testing on the implementation details of the dependency instead of how it should behave. Not sure if I'm making myself understood there. But moving up in levels of complexity, we have mocks. And the definition is, can dynamically simulate behavior and be used to verify its expected usage. I think code here is also going to help better than trying to explain it with words. So going back to the old base test case here, if I make a mock, and a mock is something you normally do with a library or some sort. You don't really write them yourself, or at least the dynamic part of it. But what it allows me to do is say, I can say, I want a mock of the iUser repository. And when someone calls the get user by email on that, I want, with any string really, I want this user back. And at first glance, this might seem like equivalent to a stub, because it seems sort of static in the sense that, well, you get the user back with these specific fields. But it's dynamic in the sense that you can actually do this per test case. So you can sort of dynamically, per test case, define the behavior that you want the mock to have. And that makes it more dynamic than a stub. And further down in the test code, you're able to verify its expected usage. So you can sort of check the implementation details of it. You can check, did something called the add-user method? Did something called the get-user-by-email method? And the mocks are great for that. So it's sort of a second assertion layer also in terms of the dependency. And I'm sure there are many people who used mocks in this room and really enjoy them for this reason, because it's really easy to quickly get sort of started defining behavior per test case and just setting up things how you'd like it per test case. So it seems like a silver bullet, but I have to sort of compare all the different alternatives here. The last in the list are fakes. And the definition is fully functional, or relatively, I think is the keyword as well. Relatively fully functioning implementations for testing, for example, an in-memory database. And I'm not talking about SQLite, by the way, when I say in-memory database. So a stub, or rather a fake, is just a stub taken far further, really. So it's an actual implementation that you build, but with more complexity, because instead of statically doing stuff, you're actually dynamically doing stuff. You're sort of faking the fact that there is no database really running under the hood there, but you're sort of masking that through a fake implementation. So what I've done here is I've added a users list, and you're actually operating on that users list inside the fake. So when I get the user, I actually try to get it from the list, and when I add it, I actually add it to the list. So it has real behavior, but is it production behavior? That's another question, and we'll get back to that. So these are the three options, and I want to sort of compare them. And when I'm saying it's the three options, it's the three usual options people go towards when they want to write test codes. And I want to compare them and upsides and downsides, etc. a bit. And the sort of quickest, easiest point to make is that the last normally has some sort of internal state. The first two does not, which might seem me contradicting myself, because didn't I impart some sort of state-ish behavior on the mock while setting it up? But I think that's a bit pedantic, because you can't really reuse and expect the same sort of behavior then across different tests. So to my mind, it basically has no internal state other than what you defined then and there for the test. And the downside then is that you can't really impart any side effect either, because it has no internal state. And to go on further, I find sort of stubs to be so an inferior option here, so I'd just like to even drop it from the list and just go on with the other two, because there's so many downsides to use it unless you have no option at all. But another downside of mocks is that it tends to make your code more specific and brittle than maybe you'd like. Which seems maybe weird, because you can do what you like per test case, right? But what makes it specific, again, is that we're testing on the implementation details of the account service and the dependency, the repository. We are testing on how the code lines are written right here and now. That is what we're testing on. You're presupposing, and that is sort of the bad assumption then maybe, that code will never change. That sounds like a ridiculous statement when I say it in a room full of developers. So, and we're also presupposing sort of that, not even taking the account service into account, that we, wow, pun. What if the dependency changes? Or the actual contract changes? What if, for example, we take the user repository and we want to change that? It's no longer get user by email or add user with string and password. It's get user by ID and add user with the whole user object, because the user object grew during the lifetime of the solution, and we have so many more fields we want to save when we add the user. Which completely changes the premise, the code that we wrote in the test code, which it is built upon. So if I take this code, I have to rewrite it to instead mock and set up the add user method in another way and the get user by ID now. And as well, I have to go down the list and I have to change how I verify the expected usage as well on the mock. But do you see where we are now? This is where we are. We're back here. Mocks are a tool with strong virality in your code base. And what I just changed might not seem like a big deal, but you have to multiply that by the number of places you use mocks, and especially mocks around the same dependencies. And that can be very many, especially if you break up your solutions in the way I've done now and test them sort of in small isolated components. So I'd then ventured to say that mocks are and makes tests specific and brittle and subject to sort of continual change. And at this point, it might seem with 3 red signs there and 1 green by fakes, I'm pushing you into the direction of fakes. But they have their own downsides as well, of course, because if we rewrote our previous fake to the new contract, and we sort of, what we're trying to simulate here, right, is, again, that there is some sort of database or some sort of backing store for the data that we operate on. But as you may notice, when I add the user, for example, I'm not checking if another user or if the same ID exists already inside the list. That is behavior you would expect from a database. When you try to add a row with the same primary key, you will get a duplicate primary key exception or something like that. And that is, of course, easily fixable in some sense. I'll just use a dictionary here or whatever. But the reality is, services that we use, and especially dependencies that someone else has made, which we sort of just want to sort of abstract away, they are complex in very nuanced ways. It's extremely hard to write mocks or fakes, for that matter, especially fakes, that can properly simulate the behavior of the services that we use. I like using fakes for very simple things, but it is such an uphill battle to do this for different types of services. For example, databases with different behavior in SQL query languages as well. Which is why I wouldn't even recommend using SQLite, for example, in development and then use another database provider in production. The nuances are too many. So, trying to fake proper services is a continual uphill battle, and the hill just gets steeper as you start upgrading the dependencies, and the way you faked it before is no longer valid. So at this point, it may seem that, okay, we have no options at all. We can't write test code. Of course we can. But the examples I've shown here, and it's on purpose, have been broken up in very isolated small parts. And then I have to go back to this quote. Because we're checking on specific implementation details and maybe behavior in small tests. But if we take this philosophy, this tweet at heart, you shouldn't break up your tests into small batches. You shouldn't isolate components, because it has diminishing returns, both in invisible work and management, but also in actually testing real behavior. There's a lot of work. So, to my mind, you should test more system-wide behavior and hopefully the important application flows. So write less tests and tend towards integration. And because this will then sort of push you into the direction when you think system-wide into architecting your test code as if running in production. If you take this also to its logical conclusion, the answer becomes clear. Don't try to fake or mock or sort of rebuild the world by yourself. You should just test with production equivalent services or dependencies. But what does this mean? Does it mean, okay, I should start like provisioning databases in Azure and using that in my test? Or what is the answer here? And, well, sorry, went back and went forward, and there we are. These are good principles to follow when you do tests. Reproducible and isolated environments, so you'll sort of end up being able to run the tests anywhere, both on your machine and the CI/CD pipeline. And deterministic test runs. In other words, as Mikael complained earlier today, if tests are flaky and they tend to go from red to green without the code having changed, that is obviously a problem. So that is not a situation you want to be in. But I think the most important bit here then is do not use shared infrastructure, because that is infrastructure that by its nature will change all the time as well and become flaky and also make it more difficult for you to reuse across different environments. And people who know me well will know where I'm going with this, but to my mind there is a logical conclusion here as well, and that is using test containers. People are humored in the audience, I hear, because I love test containers. People know this, but for those who don't know about it, what is it? There are many different ways it's pitched on the website, but the way I like to think about it is that test containers is a library for management of Docker containers from code, which might not sound impressive sort of by itself, but it has a lot of subtle strengths in use. It allows you to test with real dependencies. So it provides you with throwaway, lightweight instances of databases and services and stuff you normally use. And because it uses the Docker host as a foundation, which pretty much everyone has installed today, even on CI/CD pipelines, you can pretty much run it anywhere. And it supports many different languages: .NET, Java, Rust, Node, Go, you know. Take your pick. And here I have sort of just to demonstrate that the ecosystem is pretty rich too. They have a lot of pre-built modules that allows you to get like quickly started with any type of service that you normally use. But you're not sort of limited to this. You can run anything you want, really, as long as it's a Docker image. Even stuff you sort of also have as Docker images. And this makes it sort of easier to get started with them and configure them, etc. And I'm not going to dive a lot into the architecture of test code and etc. But this is sort of the basic life cycle of how you would use it. So you sort of provision it and start it up in the start setup part of your test code. Then then test containers sort of takes the job of provisioning all the things it needs or the containers needs, like network and ports and volumes and everything it needs to run. Starts them on your Docker host, and then they are available for when you run your tests. But the nice thing about test containers as well is there's a lot of built-in automatic in cleaning up the resources after the test run. So when test containers notices that the test run is done, it will kill the containers, it will remove them, it will free up all the resources, and basically it be like it never happened in some sense. The perfect crime. And this gives you the principles I talked about earlier. It gives you reproducible environments everywhere. It gives you isolated environments that is only for the test run and is gone after it's done. It gives you deterministic test runs as well, because you can provision these containers with exactly what you need then and there to enable the same scenario every time. And it also then gives you, of course, production equivalent dependencies and imparts real behavior to when you're testing. So I'll just show a quick code example on how to use it. So instead of faking, mocking, stubbing, whatever, the repository, just use the production version of the repository, which uses the actual database. That is sort of my point. And yes, again, naive, simplistic, not good code, but it shows it in principle, I think. And then in the test case, you can use test containers to set up, for example, a PostgreSQL database, start it, send in the connection string into a database context, give that to the repository, and then give that in turn to the account service. And the point here is then that all of this infrastructure, all of this behavior, all of these dependencies are production equivalent. You're running with the exact same code that would run in production. There are subtle differences, of course. I'll give you that. If you're running, for example, a managed database in Azure or GCP, that might not be exactly to sort of the byte, the same thing that is running in this test containers, or the networking might be different. But it's production equivalent, and that is the principle here. And I wouldn't really write tests like this either. Again, I think it's too broken up. I would instead scope this up to be more system-wide. Try to hit some other point. It doesn't have to be end-to-end in the UI. It doesn't have to be necessarily either in the API, but at some level that tests wider than if you go component by component. .NET Aspire for .NET developers is another okay, cool option, which is getting better. It's not quite there yet, in my opinion. There's a lot of sort of work in getting it to run tests, but it works. So it can also provision up services for you, and then you can test on them, almost like test containers. So I've implemented that in one project, and it works totally fine. It'll probably get better in like a year or so, I guess. So stay tuned or something. All right, so just to close up, after sort of giving concrete tips on tools now and how you should think, I want to also impart some more tips, or rather, just to summarize the tips in terms of the mindset you should follow when doing tests, and what I think is important with them. And the first one is less is more if you test the right things. If you don't test the right things, then less is bad, obviously. But the right thing then is to increase the scope of your tests, which I've tried to hammer in as many times as I can. Like, for example, spawn your website in a browser and just look, is anything there at all? If you have all the infrastructure behind that, that is a great test. It's an awesome test. Everyone should run home right now and write that test, because it's awesome. But I hope you go further than that, of course. Test behavior rather than implementation. Test what you want the thing to behave like, not what the lines of code are. If you have to presuppose how the lines of code are in order to set up your test, that is the wrong test, because you get a lot of pain down the line. And to be clear, I'm not saying you have to test everything like a black box, like this thing you built, the code base, is not something you have any knowledge about, so you're going to approach it like it's like a strange animal, and you have to sort of prod it to understand how it works. You can, for example, check the database. Did this row, was this row inserted when I did this thing over here? That is a fine thing to do, because it doesn't cost you a lot in terms of the virality and changes and code change coupling in the code. Your database should probably change maybe a bit more often, but less often, or ish as often as the API you're sort of approaching here. So, but the things between them, they change pretty often, even though we don't think about it. And last but not least, I have to hammer this home: tests with production equivalent dependencies. It's really important. There are room for the other tools I've sort of been dunking on this whole talk. But don't reach for them first. Even though they feel productive, even though they feel sort of nice to work with, they'll cost a lot down the road, especially if you overinvest in them. And that's my talk. Thank you for coming. Hope it's been of some help.
Tack, tack. Hello! I'm Jacob. I'm mostly a developer, sometimes a designer, and I'm fagleder in Variant Norway, which is to say the best translation I've heard so far is guild leader. So that's a thing. Recently, I've been fortunate enough to work with a lot of colors. Where I'm at, we're doing a white label solution for kind of banking, mostly credit cards and other credit products, but also high interest savings accounts. So we launched a new platform this year, and that's going to replace some old ones. And yeah, the kind of one of the driving complexity factors has been theming. So the one that we've got now is just swap out the color. Everything's blue, everything's red. But we got to do a new take on this, and I was fortunate enough to work with a really great designer who did a lot of work on design tokens. Lene, for those of you who know her. And we began to experiment some with OKLCH. I'm just going to try to say OK, because saying OKLCH is going to take a lot of time. So one of the a lofty goal was to have one color to be one palette or a set of swatches to make theming easier. So yeah, this is my talk, how to perhaps change how we use colors in web development or just design in general. But before we can dig into that, let's talk about Hex, because Hex kind of sucks. Not that Hex sucks, but it sucks. Because it's just a kind of a result of color pickers, right? So we pick a color, and a color pick is a really great abstraction, because we rely a lot on our eyes to see stuff. And Hex is just computer speak for RGB, because it's a set of six characters or numbers, which, when taken apart, translates into RGB. And you could theoretically understand the syntax. Many of us probably should by this point, just by being exposed to it. But no one. I mean, I know of a white color when I see one. And black 0, 0, 0, 0, 0, 0, right? And then I can do badass and stuff with. But yeah, it's a terrible color format for making color systems. So a few years ago, HSL came along, and I thought, yes, this is it. This is how we can do colors and systems. It was invented in 1970, so that kind of says something about it. We probably didn't know a lot about colors then on monitors and design systems, right? But it was widely available in browsers in 2020. And yeah, just let's explain the syntax. So we got HSL, stands for hue, saturation, lightness. So hue, that's just the color we write. We go wee. Yellow, it would be found at 50 to 60, green at 120, cyan at 176, or the like, blue at 2. So yeah, you can read numbers, I don't have to. And then you got the L, which is lightness. And that just increases, right? So when we increase the number, we increase how much light there is behind it. And this goes up, 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 until we reach 100%. That's so. And also, I should mention, saturation here is set to 0, and the hue is 0. So hue, if you were paying attention, hue is red if it's 0. Then saturation. Now I've locked hue to 120 and lightness to 50%, and you can see that with when we increase the numbers, the color go up. Color goes brrr. Wee. Just kidding. And the 100 is obviously the most vibrant color then. And let's have a look here. So we got red, right? 0. We can decrease the hue, so which goes to 360, right? And isn't yeah, this looks decent, right? But HSL hides a dirty secret. All right, that's that it's not really great with contrast. So if you work in design systems or with colors, you know yellow, right? Yellow is horrible to get contrast right. You're trying like, oh, that looks right. Nope, doesn't. So if you kind of get rid of the so I just turn gray filter on, right? And you can see that this 10 here is a lot darker than 10 here. And you can also see at 40 at orange and red. It's not very, that's a distance in contrast. And you can also see it in blue and purple. Moving on. So if you were to, Elise's, talk about accessibility, you know this number, right? How much contrast there is from this text to this background. So when we got just no saturation at all, and we get, this changes nothing, right? Because there's no saturation, which means no color, just gray. We add some saturation, right? And if we we change the background. And you can see that kind of varies widely on how much contrast we're getting, right? So it's from 8 down to, oh, that's a lot of contrast, right? This is still good, right? But kind of, because this is black, obviously. But if we were to decrease it and still have, you'd see that, yep, there's still a lot of changes in the number. So it's not consistent. So the problem then, HSL is bound to sRGB, which is a color space that were invented a long time ago, probably when CRT monitors came along. And it has all the usual suspects of color functions that we've heard of, like HSL, RGB, and there's a lot of HSV, but they're kind of based on the same color model. And the color pickers too uses sRGB. So if I were to change here, you can see that in blue, it kind of becomes darker. So it's not, we can't really use a color picker either to be like, yep, here we go, and then I turn it to the, yep, nope, that's not the same. Even if we change then to down here, it's just in the same kind of space. And then we got the other stuff, that is sRGB only covers 30% of the human visible, the colors we can perceive. And then we have gotten a lot better technology when it comes to displays. So the point of why I'm making this talk is okay. Let's not do that tongue twist again. Okay, so it's based on research. So this is very modern in like web technology. This is as modern as it gets. Like the science and the fact that it was created, I don't know, maybe 4 years ago by a Swedish dude named Björn Ottosson. And why it's cool, why it works, is that it's unbound from any color space. So it's based on how we perceive colors rather than how a computer wants to show colors. More on that later. And that we get more color because it's not bound to any specific color space. It means that if our screens become better, we're still using the same format. And of course, it's perceptually uniform, so we'll also see that later. And yeah, it should be worth noting that it's both forgiving and unforgiving at the same time. So HSL and the other, when you get them a color or a value, you're always going to get the color, even if that means like distorting colors. That doesn't make sense, but yeah. The syntax is kind of the same as HSL. We got lightness, and then we got hue. And then in the middle here is the kind of where the complexity lies, which is chroma, which is kind of the same as saturation, but not quite. Yeah, so here's the hue wheel. And we got an OK wheel. And if we were to like turn on grayscale here, we can see that it also shows something that is important. So, and as a bonus, we get better gradients, right? That's blue. That's blue. That's white. That's white. Why is it purple? I'm just asking. So it kind of resolves gradients a lot better for some colors, not every color. You can see that when we're turning it about, you can see where it's in some cases it's very good. In blue, it sucks. Somewhere here, it's kind of awkward too. Oh, wait. All right. One moment. There should be another thing here. Anyway, yep, let's instead, I'm going to do that one later. I'm going to do this one before. So to better illustrate how OKLCH works, has anyone been on this webpage? Some? Yeah. And how terrifying was that? Yeah, so HSL is kind of, if you were to look at a map, and it is a flat map, like you want to hang a map on a wall, and it looks good, like it fits. But sometimes you want a globe, right? Because that's when your coordinates are very important. You kind of want the complexity of a round thing. And that's kind of flat maps works for when you just need to look at something small, and then a globe would be better if you want to do the whole thing. So this is a visual representation of OKLCH, where you have on one axis it's just lightness. It goes from light to dark, and another one is from hue, so from red over here to red, or 0 to 360. And then in the middle, you can see that there's like valleys and mountains. And these are chroma, right? So it's how much color there is on a given hue with a given lightness. We can see that there's color on different places, so to speak. And this is the complexity that our eyes actually have, or in compared to or in context to screens, right? So we couldn't. That's why colors, yellows are hard, right? Because there's not a lot of yellow, but there's a lot of green and a lot of blue. So, and it's better illustrated here. So, and because OKLs is unbounded from color spaces, we can see that there are more colors to be had once the screen technology gets better. So P3, that's kind of all the high-end mobile phones, the last, I don't know, many years. And Rec 2020 is like very good high-end TV sets. And then you get a lot of color. Yeah, so this kind of works if you look at this. If you lock this one, you can see that This is how much chroma we can get from this. Given this lightness, I can change chroma this much. So you can see the center here with a kind of crosshairs that you can get pretty high up. And also this is what I mean by still forgiving and unforgiving at the same time. You will always get a color, right? So if you were to crank this up to max, you'd get the most vibrant color there is at this given hue. And sometimes you get very funky results. But anyway, that's kind of how that works. And so my kind of end game here is to show what is possible in this. So imagine you got a color palette, right? And being the good designers or developers that we are, we've instead of just using 200 straight up, we say, yeah, 200 is probably strong text, foreground text. And the background here is probably 800, but instead of saying that, we give it a name. But and we can see that the accessibility checks out. Cool. But what we could also do then, because we know that it's perceptually uniform, and we've like, yep, we've made sure of it, in which I'm going to explain later. But then we could also like change the color. We want a muted blue. Yep, that's still good. We're still good. Nope. Yep. Okay, so that one. No, don't do that one. But this one and that one. And then we could like, yeah, we could do green, I suppose, or we could do red, and we could do purple, blue, and we'd still get like at least a guaranteed minimum of contrast. And if you would do this with HSL, you kind of saw that blue would totally crash the party and be like, no, I'm not doing that. So, and because we've bound them to kind of to be a thing instead, we could also invert them, right? Because that would just mean taking from the other side of the scale. Also, this is kind of just to show what's possible, right? So we could take any color, pick it here, do it there, biddy-boo, biddy-bee. That looks nice. And we could invert the whole thing, right? So just from here to down there, it's the same palette or scale, if you will. We don't have to deal with stuff like color 300 red or color red 300, color blue 400, color whatever, and a number. Instead, we just do color all the way. And why this is nice is this is where the magic happens. So the other example was HSL. This is okay, which is also, I should explain that why it's okay is because the former, just LCH, it wasn't that good, but OK LCH is okay. Anyway, so we can see now that when we're turning up the chroma and hue, you can see that that number there stays kind of the same in much larger degree than what were possible in HSL. And this could really work to our advantage. If we were to, so I've locked the chroma or the hue to be the same as up here. We could see that, yeah, we could have some text with just as a monochromatic kind of thing, where we want some so imagine just as is usually the case in design system, then is that you do black on colors because it's easier. It's a bit harder to code the things that it's, yeah, we should change the color, but then you also increase how much complexity you need of your design system in general, like because black on a surface kind of looks, it's so much contrast that it kind of sticks into your eyes. So instead, we could lean on the OKLCH and be like, yeah, you could take the wheel here and be like, that's much nicer to look at. And because this is about contrasts, we're kind of not just talking about contrast as text on a background. It's kind of contrast in everything, like borders, icons, illustrations, text, backgrounds, colors, and you get the point. So this is kind of a usual thing to see in design systems, right? Where you have a thing which has a lot of color to carry meaning, like you get success, danger, info, warning, and the whole point of them is to indicate with color what you're supposed to like carry meaning in a way. But if we were to turn on grayscale here as well, you'd see that this looks kind of familiar, right? I'd certainly say so. Oh, so this is kind of a good practice too if you ever want to do semantic colors or semantic tokens or whatever you want to call it. That the name of the border doesn't have to be linked to a certain color. It could just be that this color is called, I don't know, border strong or border weak, border something something. And then you'd essentially often you'd also give it a color name because you've built the color system on top of everything predefined. So, yep, let's build a palette. So the things you saw earlier in the demo, I kind of have to explain how you do it as well. So we will need a curve and scale some steps. This is if you've ever been in a design system with colors, there will be names on the steps to indicate how much color or how much contrast there could be between them. And any hue will do, and we need some way to do chroma. But let's get back to that one. So Lea Veru has done some research on how design systems do colors and plotted them on some charts. So here is IBM Carbon, and we could see that lightness is kind of that's we can see there's a pattern here regardless of the color, right? We can see that lightness kind of, so we can assume that, yep, that's a line. But in Chroma's case, we could see that there's a lot more going on, and hues are just like, a straight line. And this kind of repeats itself on other, so let's look at Tailwind's color system. That kind of also follows a certain pattern, right? In that it starts up here and then trails off towards black. And I should say that these systems are probably done before OKLCH was even a thing. So it's kind of impressive that someone managed to make it this uniform across several colors anyway. And you can see that there's a pattern here as well. And as same as with the hue, it's a straight line. So with that in mind, we could probably say that, yep, we can stick with the same scale or curve at lightness, and we can just give it a hue, and that should be good. Also, this is the example for you can also see here. Now I'm just gonna not turn on grayscale there. And GitHub Primer, kind of the same. Lightness, whoop, the same. Chroma follows a certain, but as you might have noticed, the chroma is where it separates between all the color systems. This is where the magic happens, so to speak. And hue, still the same. I don't know what's happening here, but Oh, yeah, it's black and white. Sorry. Anyway, back to here. So we would need a lightness scale. And this is what gives us the contrast. So this is kind of the easy part. The easiest part of this is just defining a color or lightness scale. That could be the same throughout the lifetime of a system. You could tweak it as long as you kind of settle on a naming convention, you'd be fine. I wouldn't be angry if you did it any other way, but it's kind of, please keep in mind that this versus this should kind of be like how much contrast between something. Even if you as someone who makes a color system would at least keep in mind. And if you decide to do semantic coloring or semantic classes, that's where you'd put it into words instead, like subtle versus weak versus strong versus something else. And this would be the same as you saw, like this curve right here. That's the same as this one. Pretty straightforward that. Now chroma, on the other hand, this is where the hardship lies. As you saw, because of all the valleys and in the mountains, it's kind of hard to do it properly. I don't know if someone has been on this site to try to make a color scale at some point. Someone? Yeah, I see you. It's kind of terrifying that you're trying to do it and you're like, and I feel like, is this better than color picking in a color picker? It's kind of hard, but it's honest work. So yeah, let's try to make a scale then. So we're using the same kind of the same scale as here, just put into boxes. So this would be a representation of if there's no chroma, this is what it would look like. Because we haven't added any colors yet. And you can see from my little practical guide here that it's not a lot to a little gives a lot. And while it's theoretically possible to go beyond 0.4, we don't have the technology. Anyway, so let's do some add some chroma. Nice, all right. And it's kind of easy to so I've added some extra information here to relay when things are not as they seem. So here we can see that if by the swatch here with the most amount of light, we also have the least amount of color to go up. So it's because we got so much light, it's so close to white, and then you're trying to add color to this. It's like, nope. In this color space, I can't do. So this is where we would get a fallback colors, kind of like we had over here. So this is where unavailable on any device actually. Yep. So we can't do that. So I have to turn it down, and it's like, nope, can't do that. And at some point, you kind of get that there is a lot of color here. Oh, not in sRGB, but we still got P3. So that's because it's on a screen that can produce a lot more color. But this is pretty damn hard to just do per color, and it kind of sucks, to be honest, if you're gonna do this, because you kind of have to do it the same as hex. You would sit and pick colors on each and every color. That I'm sorry about just saying colors, and I know that it's hard, but is it a swatch? Is it a palette? I can figure out what the naming convention would be for one set of colors and every swatch or color inside. Anyway, yeah, as I said, it's no fun. And let's instead have a look at how we could do it with some nice CSS instead. So recently, in CSS, we got something called relative colors, which you can take one color in a color space. So in this case, LCH. So we give it a hex color. Yeah? And then we get the values from that color. So here we go. Here we've got red, right? So if we were to give red to this color, this variable, we get its lightness, its chroma, and its hue. So this color right here has exactly the same color. And as I typed that out, it's just the same color, right? We haven't done anything by it by now. But if we were to take the same color as we did, and then on lightness, we want to give it another color. That would be here. So lightness 20, we could decrease, increase, right? And we could do the same for chroma instead. So lightness would be the same as the color we picked. And then chroma, we would want to overwrite with a variable here. So it's 0, which means gray. And if we start adding some chroma, you can see that, yeah, at some point we would be at the same place as this one. And if we were to change the color, you can see that it changes as well. So that's kind of a very, very nice feature to have to make a color system. Wouldn't be possible without it, unless you want to shoot and tweak. And it's kind of, if you imagine a type scale or something that you can multiply or something, you could use it with calculations. You could do anything really. So like if, for example, a hover state on a button, instead of having to say, you should be this specific color when I hover it, you could say like, just subtract 10% light. So you then get a hover state, right? Instead of having to define all the colors, you can do like, I already know the color, just a little bit darker, please. So you could use math inside of it. Does this make sense? Yes, yes, yes. Sorry. Anyway, so then we could like take this to try to copy or put this color into a palette instead. And then we could clone it. And then we could do another color. And another color, right? And that's kind of the thing here is that we're, so with the same lightness, but we've also locked, so chroma is the same for whichever color I choose, right? We do nothing with chroma here. We just do lightness. So we change lightness. Lightness 10 for this specific color. We are interested in its hue and its chroma. And then we set a specific lightness for each and every one of them. So imagine this being like color 100, 200, 300, 400, 500, and so on. So we're just interested in chroma and in hue, because those two then lets us do this, and we're just adjusting lightness. That means we could pick any color and make a palette from just one color. And if we want to make it less saturated, we would give it a less saturated color. And if we wanted to be more saturated, we would give it a more saturated color. Problem though is that, as I showed you in the other demo, which when you're going towards a very much light, you'd essentially get white, right? So there's not a lot of color in white, but this then doesn't account for that. We're just using the same chroma. So if we're taking like a really acid kind of purple, we get some odd result up in here, because this should be white now, because it's 100%, right? My cool thing is that it's when it works, it works. Like when you haven't picked any crazy colors, it kind of works, but not really. And that is because of chroma and because of how it works kind of in this situation, where you'd pick a color with a lot of green, so you'd still want it to taper off at the sides, right? Because white and blacks, you can't have a lot of color in white or black. You'd need it to taper off. So that is why we need some math. And I'm not good at math, but I'm good at CSS. I'm not gonna try to explain it, but we can do a lot of math in CSS these days. So instead of having to define a chroma scale for each and every set of palette steps, so for green, if you want, you do a scale for green and a scale for red and a scale for pink or yellow. Instead, we could be like, yeah, we can make a kind of a scale for each and every one of them, and then have some math like this sine function, which takes in a, so this would be the number then, and multiplies by pi. I could just hear myself. Like, you could just multiply it by pi and sinus curve, but important thing is that it works. And then use the C value from the color we picked, right? So a higher, like a more vibrant color then would result in a, oh, did it, the whole presentation? All right, cool. A color with more color. You can see why this is hard, right? Color with a color. Anyway, a color that is much more saturated, you'd get a higher number here, right? But because we're doing the sine wave and the pi thing, it could taper off instead. So that means that we're kind of tapering off at the edges, and depending on our curve, on how, or rather how we do this one, all colors could taper off at the ends, or the extremes, rather. Yep. And that's kind of what this is about. It's not so much about how to set up and hand-tune the colors, but it's more like you could use one color to give you a set of steps, color steps. And so, yeah, we could have a grayscale that just, yeah, we would like a tiny amount of green into our grayscale, because maybe that would be nice. But with the same formula, we could like be, yeah, I want my success color scale, and that would be, let's make it. Is it going to be a muted kind of forest green, or it's going to be an acid green? I don't know. But that kind of, if you made a formula, that's what you would decide as either a designer, preferably a designer. So you could make the formula instead of making like hand-tuned decisions in a color picker or the scaling part, just by choosing something in here. So this could be, if you want to call it green, in our or a red, and just be like, let's see, it's going to be over here. Yep. Hopefully this should be a lot more uniform. Yes, squirrel. Yeah, yellow. Okay, you all know this is gonna look, or some of you might look, then yeah, that's gonna be a bit, yeah, but it should shake out too, even though it's a little bit darker. Probably couldn't tell on that screen though, so that's okay. Yeah, so back to this then. So success doesn't really have to be like a success color. It could be any color, but we're just giving it, define a color and a formula which allows us to not think so much about each and every color. I said colors many times. We're using the color picker to decide one color, and then we get the entire palette for that specific one. And the same, let's say, yep, we could call it red, we could call it danger, doesn't matter. We just give it one color, and then we're good. And info, it's like, we're using this, by the way, for our on the project I'm working on. Is like, yeah, maybe we do want to have a different blue for dark mode, right? That would be entirely cool because it's just one color to give us all the colors. And dark mode is kind of, you don't need as much color. There again. You don't need as much saturation on a dark mode than you do in a light mode. Because in light, you're fighting towards, or you're fighting against white, which is so much light. And in dark, you get almost no light, right? Because it's dark. And just with a little help of my friend Semantic class names, you'd also get dark mode for free and inverted for free. So this is the same scale, but it's just other color names, or rather class names for this. And again, it does look. I mean, these are not the greatest examples of designer chops, but it looks a lot better than having a white. If this would be a white color on a muted green, it would sting. That contrast would be too great. So we could still be like, yep, that checks out. Use contrast twice. It checks out. That one checks out. That one checks out. Yep, and this one too, because we've defined the formula and established some rules, and that just makes it a whole lot easier to understand. Yeah. So some of these stuffs are not what would you call the browser supported, but but at least the OKLCH part, for sure, that's no problem. I think it's about 95% plus, which should be cool. But the relative colors part is maybe not so cool. So if you'd want to, you could you could still do it, but you'd need to use some JavaScript to give you the, you'd still put one color in and you get a scale out. Not as, you couldn't do fancy stuff like picking a color right here, but it would still essentially be the same because the math, the formula, it's still the same. Yeah, oh yeah, I had a slide. Okay, so I left this one, and I'm not gonna try to say that. But it's pretty much it. You take a color, you have some curves. So you, pro tip, use the colors. So this is the same package as the one I'm using to do a fallback in JavaScript, but has a lot of interesting finds on colors, and use some math so that you do not have to do the old dance with trying to define stuff. And then you'd get a color, and like in Figma, if you're doing modes, this would slot in perfectly for modes. Like you do a frame, pick a mode, cool, it's the same. This is basically the same. So kind of if a developer tells you that's not going to be possible, I saw a talk. I know it's possible. And then you can refer them to me and I'll talk them out of it. Or into it, depending on, yeah. Anyway, so that's kind of what I've got. If you got any questions, I know this was like a phew, and probably, I don't know, too high of an abstraction or something. But that's all I had. Thank you for your time.
Okay, hello. We are here to talk about why we should put secrets in Git, because you've all learned this, right, that you should put secrets in Git. And yeah, you came here to know what the F is he talking about. But of course, it's just bait, because the real name of the talk is why we should put encrypted secrets in Git. So yeah, I kind of ruined that already. So why Git? Your Git repository, it tells a story, right? It tells how your code base has evolved. It tells about your data schema through migrations often. It's version controlled. Your configuration, your app settings, your package.json scripts. You get Git blame, right? You can see which colleague introduced the bug to production. You have a distributed backup of all the code on everyone's machine. That's great. We can do atomic changes that prevent drift, because we usually have our infrastructure as well, right? As infrastructure as code together with the application which runs on it. Disaster recovery becomes easier, and if we're doing GitOps, it even is the source of truth for the state of how things should be. But hopefully your repo doesn't tell this story. Secrets, we just can't get rid of them. We need secret in the applications we make. There's a lot of ways of getting around it these days with policies and managed identities and that kind of stuff, but it's still a part of what we do. You probably have your .ven file, maybe Git ignored, maybe that secret is not for the production environment, it's just for the test environment. But as developers, we often follow the path of least resistance, right? So who here has sent a .env file to another developer on the team to onboard them? Exactly. I did that at the Booster conference, and like almost nobody raised their hands. I was like, you are a bunch of liars. Everyone has done that, and it's only natural, but usually we weigh the risks. But the point I'm getting to here is that by including secrets in Git, we kind of complete the narrative. It's kind of the last missing piece of the puzzle to version our secrets together with the application and infrastructure that uses them. So yeah, that sounds good. Like, yeah, let's put encrypted secrets in Git then. But that's the easy part. But how do we take those secrets and make them available for the application? And kind of how does encryption work? Okay, we put it there encrypted, but if our application is going to use it, it needs to be able to decrypt it. So to get into that, I just wanted to quickly kind of get into how encryption works. To do encryption, we use keys and algorithms, right? But basically, we need keys, and as it says here, we can encrypt and decrypt, or we can one-way encrypt, kind of hash, and you could never retrieve it. But in our case, we're interested in kind of this two-way part. There exists two types of keys. One is symmetric keys, and it's basically you all have the same key, and it can both lock and unlock. The good thing about symmetric keys and why this is what we actually use, it has to do with it's really fast and effective. So mathematically, it's the best thing to use when we're sending a lot of data through the internet, right? And we want it to be encrypted, and we have to decrypt and encrypt all the time on each side. But key management is complicated with symmetric keys, and of course, if one party loses the key, both sides are kind of compromised. And yeah, if you use one symmetric key to talk to 100 different people, you would need to handle 100 keys to not lose control. You would lose control, is my point. So we have asymmetric keys, which is a key pair, and this every developer uses daily with kind of SSH key for pushing to GitHub, or you have a SSH key to log on a server, but also every person in the world uses this every day, because this is how the internet works, through HTTPS. So you have two parts of a key. You have the private key that you never share to anyone. You keep it safe. That one can be used to decrypt things that have been encrypted with the public key. And it can use to be signed signatures, which can be verified by the public key. So you can give the public key to whoever you want. They can encrypt a message to you that they know that only you can decrypt. Or they can see a piece of information that you have signed with the private key and know that there's no deniability that that key actually signed that message. But still, when we use asymmetric keys, the goal is to achieve a symmetric key because of speed. So in communication, we use asymmetric keys or certificates, or which is basically asymmetric keys, and we get a symmetric key because that's fast and one key for everything. But the problem with handling keys like this, I'm sure you all have a .ssh folder on your machine with some keys in it, and yeah, maybe you get a new Mac and then that key is gone. Ah, shit. Then you add a new key on your GitHub and you keep going, right? So it just shows that kind of managing keys is hard, and this kind of initial trust. If I got a public key from someone, how do I know that person is the one that gave me the key, right? If it happens over the internet, that initial trust, we call it, is very difficult. So, luckily, I'm going to introduce you to a tool right now that kind of helps with all of this. It's called SOPs. It stands for Secret Operations. It was initially launched by Mozilla, but has been given to the CNCF sandbox. So it's kind of open source, is basically what I'm saying, with complicated organizational names. It was inspired, of course, by many years of managing PGP encrypted files and keys. What makes SOPs a bit unique compared to tools like Gitcrypt that can do like binary encryption of files is that it actually can partially encrypt files. So as it says here, YAML, JSON, NVENIM, and also it can do binary. But it means you can keep a lot of the information and metadata of the file. And another great thing about it is that it has support for secure storage in most of the big cloud providers, but also standard PGP keys. So I'll get back to that and show a bit about that. But it's basically just a CLI tool that you run to encrypt and to decrypt. So the selling point of SOPs is that it removes the impracticalities around key management and initial trust. And I'll show some examples. And of course, the world runs on YAML these days. I'm going to show you YAML. But you go to a dev conference these days, that's all you get anyway. This is .sops.yaml. It's kind of the configuration file, lives in the root of your repository. In this example, we're basically saying, we're not saying encrypt all YAML files. We're saying if I encrypt a YAML file anywhere in a subdirectory of this folder structure, look for fields called where the key is data or string data. And if you ever worked with Kubernetes, this is targeting a resource definition of a Kubernetes secret. And it has here pointing at the PGP key that is on my machine. And in this example, I have both the public and the private key. So I can both encrypt and decrypt. In reality, if I wanted to just encrypt and commit to the repo, I would only need the public key. But in the example here, we want to be able to decrypt as well. So if we look at this secret.yaml file, this is just a normal resource definition of a Kubernetes secret. And you can see it has some string data. And this is a nice little home lab example, right, with PhotoPrism. And it runs on MariaDB. So it has basically 3 passwords. And if we use SOPs on this file, based on the sops.yaml that we had before, as you can see in the gray under here, we just run this command and we pipe the result out to a new file called secret.enc.encrypted.yaml. That file will be encrypted, so that one we can check in to our source control and version control. But the cool thing is that if we look at that file, we'll see that it actually looks a bit the same. If you start reading from the top, you see we're preserving all the Kubernetes resource definition metadata. But if we have a look at the string data, we'll see we kept the keys, but the values are gone. But they're not either. Also, the value is not just binary data. It's actually metadata inside there about what was used to encrypt it and things to kind of find out for SOPs to know how to decrypt it. But this even though I use my PGP key, this is not encrypted with my PGP key. This is, SOPS has created a symmetric key to encrypt these values. And then it has, in all this metadata below, it has encrypted that symmetric key with my public key from my asymmetric key. The reason we're doing this is, again, key management, because you maybe want several people, your whole team, and maybe some backup keys to have access to this one. So this is a way of making sure that we can share that symmetric key with a whole team, so more people are able to decrypt the file, and we can add more people later without having to encrypt again the actual secrets. We can just re-encrypt the symmetric key used to it. So it's kind of a key locked away with a lock that can be opened by another key. So it gets a bit complicated, but this is all handled by SOPs, so you don't really have to think about it. But again, it's just symmetric and asymmetric keys, the same way as the rest of the internet kind of works. So, but of course, if I now deploy this with GitOps to my Kubernetes cluster will have to be able to decrypt it. So does that mean that my Kubernetes cluster needs its own key? Yes, it does. That is correct. So here's an example where I actually take that key that I said I had on my machine, I export the secret key, the private key, and I create a Kubernetes secret. Here, this is with FluxCD. You could use Argo or whatever you use. It supports that, or you can just do it manually with the command line. And I can put that in Kubernetes, and since FluxCD has support for SOPs through its secret handling, it can just understand when it gets a resource, it can see that it has the SOPs metadata and understands, yeah, I have to decrypt it before I put it in the cluster. So here's just showing the secret living in the cluster. So it's encrypted in your Git repository, and when the GitOps, when FluxCD or Argo or whatever pulls your Git repo and updates, then it decrypts it on the machine inside the cluster and creates the secret. So you have this encryption in transit as well, double up. After I've done this, I could also delete the private key from my machine and just only have it living in the cluster, for example. And I could just take the public key. The public key is, you can't do anything dangerous with the public key, so I could actually check it into the Git repository and say every time you need to update a secret or add a new secret, use this public key that is in the Git repository to encrypt it and just deploy it, because the cluster will know how to fetch it, but you are not able to do it. But that can be a bit impractical, and yeah, maybe smart to store that key somewhere, probably offline. Everyone working with encryption and keys, they just want you to print it out and put it in a fireproof safe and put it in your mom's basement or something. Offline storage. So yeah, here's another example. And now we're getting into a bit more interesting part. Here you can see it's a lot more. You can see I'm keeping my PGP key, but I'm also adding Azure Key Vault as a key from Azure Key Vault. The reason I'm keeping my PGP key is because you should never put all your eggs in the Microsoft basket. So I'm just using that to have a backup in case, I don't know, Microsoft deletes my Azure Key Vault where the other key is. So that's just a safety measure. But here you can see, this is just a nice example of seeing that the first rule just says that if I'm encrypting anything inside the secrets prod folder, it should use a different key from a different key vault, which has different access, right? And the whole point here is that we're actually creating a key in a key vault, so we don't have to handle a key at all, right? We want to get away from this key management problem, and we just want to log in. So the cool thing about this also is that I can basically get infrastructure as code for my key that I'm using as well, right? So in this example, this is a very lightweight example of creating a key vault, and we basically give a group access. Our developer group, our team, can get access. Here I'm giving key vault administrator. It's not really maybe the best to give to everyone, but for simplicity's sake, we're doing that here. And we are creating a key, which we're just calling the shared SOPs key. And we're saying, people who have access to this key should be able to encrypt and decrypt, right? And this has now been kind of access controlled by the same way and the same groups that we use for our other infrastructure in Azure. The cool thing about using Azure Key Vault for the key is that they actually use like secure HSMs, like secure hardware storage, specialized hardware to store the keys. And you also get complete audit logging, who has accessed the key and used what operations with the key. And you can do simple things like this as well. You can say that this key, it shouldn't be able to export it. So Key Vault kind of becomes your little YubiKey, because that's the special thing with the YubiKey. It's also asymmetric keys, but the private key is not possible for it to leave the little YubiKey. So you actually send thing and you encrypt it, and that way the key is much more secure. So the cool thing is now we can do a second round, and I can actually start like, yeah, for all my infrastructure as code, I can actually I can have my secrets that I want to have in a Key Vault that our application use. I can have that in my Git repository, and I can encrypt it. So if I run SOPs on this one, it will just make it into a JSON file with data and all that SOPs information on how to decode it. So I can do like binary encryption of any file, basically. But the metadata is kept as much as it is. But for this, since it's not a JSON or YAML, it doesn't do that partial encryption. So back to the .env example. If you now had this .env file with a secret that all developers need to actually test the application locally and do development, because this is the login, then I can actually just run SOPs and encrypt on it. And now it will look like this after. You'll have all the metadata in the .env file. And you'll see that the client secret, the top one, is encrypted. But the good thing now is that the only thing I need to do as a new developer pulling the code and the code base now is to just log in and run SOPs decrypt. So I log into the Azure CLI, and I'm in the developer group. I was added to that when I joined the team. I take down the repo, I log into Azure, and then I run SOPs decrypt. It will see in the .sops.yaml file that it's a Key Vault that was used for this, and we'll see in the secret metadata, it's this key. And it will just go fetch that key. Now I have access to it because it uses the Azure CLI to do that under the hood. Pulls the key, decrypts the file, and I have access to it. So the developer experience is just signing in. Of course, there are some gotchas. SOP security kind of depends entirely on key management, but here we're giving the key management to a Key Vault, right? We're making sure we use the same login and MFA as if we are logging in to check something in Azure in the portal, right? So, but yeah, there are routines on how to cycle secrets and everything, but yeah, probably the last one is kind of the most important one, right? But I think the pros outweigh the cons in this. Anyone know what this is? Quantum computer. So yeah, everything I told you now about asymmetric keys and symmetric keys, this bad boy, it will destroy it, and the internet and everything is, we're gone. This is from the Gartner 2025 Top Strategic Technology Trends report. And yeah, current encryption will break is the expectation of quantum machines. So already now we are under attack by quantum computing in a way that in what we call a harvest now, decrypt later attack. So people now are trying to store data. So when quantum computing potentially breaks the encryption we have today, they will have all the encrypted data ready to go to decrypt it. And you also have Shor's algorithm, which basically if you have the public key, you can calculate the private key. That's impossible now. But with quantum computing, we expect it to be possible that if you share your public key with me, I can calculate the private key. And of course, then the whole internet as we know it would break if that was possible. So there's some good things to read about quantum computer, but it's let's just wait till someone tells us what to do, I guess, in this one. Thank you.
Hi everyone. I know I'm the last talk, so I'll try to keep it short so that we can get something to drink. But let me first introduce myself. I'm Yuri. I'm a front-end developer in Bergen. I've been working with front-end for a long time, and I think it therefore is quite wise to first take a step back and to see what we've done in the last, well, what is it, 30 years right now? And I'm going to start with these logos, which a few of them might scare you if you've got to meet some programs made in them. But this is basically what interactivity on the web was for a long time. Starting with 1995, when Netscape, I think, if I have it correct, introduced JavaScript, a new language to actually make something interactive. Before that, you had some nice HTML things where you can start make things moving, or you could add a GIF to a page, even if you had images, but that was about it. And JavaScript kind of changed the game. But this is a time where everything is slow. There is no computing power, there is nothing to do, so the only few things that you could add is make a button or a form a bit better. And people wanted to do more on the web. We wanted to play games, we wanted to have interactivity. So slowly, we got Java and Flash as alternatives. You've probably all grown up with some kind of website where you can play a lot of Flash games. I'm guessing that's everyone here. Yeah. Well, have you played those Flash games since? No, not really. Also, Java came around and was kind of terrible on the web, where you had this loading animation and it did really basically nothing. And if you have seen it, Microsoft Silverlight, well, it felt like you were RDPing to another machine that's running some kind of very old Microsoft C# application. Not great. The biggest problem with these three compared to JavaScript is that you are just limited by the design. You don't have direct access to the DOM. You're basically looking into a window to another world, to a window that doesn't associate with the actual website that you're looking at. So that means that if you want an interactive website with more functionality, nicer button animations, that would mean you either had to make it entirely in Flash, which doesn't sound like a great idea either, or you would have these windows everywhere and hope for the best. Interactivity through existing solutions and don't integrate with the DOM. And then we continue with just JavaScript. We finally get better computers, we finally get more functionality on the web, we can start interacting more with the DOM. It turns out that no real browser thought of how to do that, so all browsers did something else. Luckily, then we get jQuery to kind of fix that. Okay, so now we can at least try to edit things there. And it turns out JavaScript is also a kind of terrible language. The syntax just got too verbose sometimes. Again, you had the problem that all browsers implemented differently, so we started introducing other languages like CoffeeScript. I think the older programmers might have known it a bit and thought like, yes, finally, a language which looks normal and is a bit easier to use. But it changed. Around the time that Chrome got introduced, a few years later on, we finally started getting the power in a machine, but also the willingness to start doing something with JavaScript, getting away from Flash, getting away from Silverlight, getting away from Java. And it made JavaScript a much better language. And I think almost everyone in the room here would agree that JavaScript nowadays is a usable language, right? Yeah, except that mostly all of you are probably using TypeScript instead. Yeah, exactly. So JavaScript is still this kind of weird language that's just kind of there that we've grown up with since 1995. It was never designed for what we're doing with it today. And the only real reason that it's running as well as it does is because engineers at Google got paid $300,000 a year to try to make it work. And they did. It runs really fast in a web browser, but we're still wasting time, still have a language which isn't really nice that we want to use, and we have no real way of fixing it. Introducing WebAssembly. Because this was very much known to people making browsers as well, that there's a missing link. You can only use JavaScript on the web right now, and we should be able to do more than that. Plus, throwing away so much computing power. Think about when you're writing a native application and when you're writing JavaScript. How many layers there are between your JavaScript running and what the actual computer is doing. Plus that JavaScript has been designed to be in a single loop. So we have to add all kinds of hacks to get some kind of multi-threading working. Not great. WebAssembly tried to make something new, like a universal language which other languages can port to and which everyone can write. A language that is much faster, that is optimized for what the CPU is actually doing. So as raw instructions as possible, while still making a lot of guarantees about safety, usability, and compatibleness. If you look at the design, especially if you read the initial papers on what the thoughts were behind WebAssembly, it had to be safe. As in, it should be able to run in a web browser. We can't trust any website you're visiting. Most websites you're visiting are downloading 20 different ads from 20 different sources who you've probably not vetted, and the owners of the website probably haven't either. So it should be safe. It can't escape the web browser. It needs to be open. All browsers need to be able to use it, spec needs to be open, and every language must be able to use it, because otherwise, what's the use? It must be fast. Otherwise, we can just go back to TypeScript, I guess. And finally, it needs to be hardware and platform independent. And I'll talk a bit more about what it means later. So how can we actually start using WebAssembly? And I've parted this in 3 different ideas on the levels that you can reach when using WebAssembly. And I'm first going to start with the innovator. And I'm going to do some live coding, or show some live code, which is always great during presentation I've seen in the past. Because I have an idea of finally being able to read all tweets again. Like now that this platform isn't really doing that well, Twitter doesn't exist anymore, but there still are these tweets from like 2009 that are valuable for me. So I've downloaded the dataset of 1.6 million tweets, which is way too much for my web browser to handle. Can't even search to it. So I've written this program in Rust, which reads through these tweets and which can actually filter through them. So I've made some kind of function that takes all of the tweets I've gotten in this tweets array. It goes through them all, filters them for this text, searches, and eventually I can query the results to know what the tweets are. But this is Rust. How do I actually get that in my web browser? I can just basically compile it. The ecosystem nowadays is there. Oh, I'm already in the right folder, very prepared. I can just build this code, and this will actually make a JavaScript package for me. And you'll see that it creates this WASM file. And on the browser side, I can now just use this directly, like I would with any other package that you would download from NPM. So I have the CSC page here. This literally just imports that package, initializes it. That's the only thing you would need to do for a WASM package to make sure that the runtime gets set up, that you can start using it, and then I can use it like anything else. It's actually part of the web now. So here I do that. I have a file input. I can read the file and just make this CSV data. If we look into this, we'll see this is just some TypeScript code, but it's actually a function that's being called in my WASM file that I compiled here. So let's run this. As you can see, I'm not a designer. At least, even not a designer enough to import some make my website be beautiful CSS file, but at least I made the dark mode, so you can be thankful for that. I can now just open my tweet CSV file, which is 238 megabytes. It will load, and here are my tweets. And I can even search through them. Like, for instance, maybe there was someone talking about refill already in 2009. So if I fill in refill, with almost no delay, I get, well, I got the refill for my prescription today. I don't know if that's what we're searching for, but it works. This is calling Rust code from the browser without any big delays, 1.6 million tweets without you really noticing. That's nice. So what's actually going on behind the scene? How does WASM actually look like? And for that, I can just make a small function, which is easy enough to show. In this case, let's make an add function. Let's add 2 numbers together. And of course, let's make this accessible from the browser. So WASM bindgen, for this case, is for Rust, is a package to make it easy for me. You could do this this is available for basically any language, not like this, but you can write C, you can write C++, Go, C# if you really want to. I don't know, Java maybe, probably not, but... and again, we can compile this. And to see what we've actually done, like how this looks like, let's go to our package folder, and then we can unpack our WASM file. So this case is .wat file. This doesn't look like assembly, but this is basically the assembly language for WASM. A lot of calls, all the functionality, and a lot of unreadable machine-like code. And in here, there is my add function created. And it's created under an identifier. So I can just search for that. And it's my function. It gets these two parameters, it adds them together, and it returns that. It's quite simple. It's not exactly what you would expect when seeing machine code, but again, this is not machine code. This is a layer above that, because we can't just start running actual binary x86 instructions on our machine directly. That would be very unsafe. That's it. And now that's compiled, I can also just immediately use it from my page. So if we were to import it, if we would call add, I can see that it's in rustcc reader, and I can do add 1, 2. And hopefully it will give me the correct results. So that's the first part. I do want to reiterate, sorry about that. This is definitely not a Rust talk in disguise. I do really like Rust. You should too. It's a great language, but I'm not. This is just because I'm comfortable in the language and I know that the WASM ecosystem is quite good. So I'm using that. But to explain a bit on what it's actually doing, how this is actually working, we should look at this slide. So WebAssembly is running directly in my browser, but it's not running directly against the DOM and our browser APIs. There's still this kind of glue that's there. So JavaScript is calling the glue, which is calling my WebAssembly and going back and forth, because these are two different worlds. In machine code, a string doesn't exist. A string is just a binary blob of data. JavaScript doesn't really care about that. The browser will take care of it, but we need to translate between these two values. So it's not as good as running directly towards the DOM, but it does give some more possibilities for that later on. What about the revolutionary? Because this is just providing some functionality in Rust. And with that functionality, we can, for instance, change the very slowest part of our code to be faster, and that's great. But what if we could actually just write our whole website in Rust? Or WebAssembly, I mean, again, this is not a Rust talk. One of those frameworks is Leptos. And I just want to show you shortly what this looks like. This is it. This is a website written in Rust with WebAssembly. And it's very React-like. You might recognize the idea of components, composability. In this case, this is a framework using Signals, if you're familiar with Solid.js, frameworks like that. But I can just make an input, which has some kind of setter and getter. And it writes my name to this other component that is then using that to get some text out. And I can again just run this in my browser. And to compile. Oh, I thought, okay, I did have dark mode. Sorry for that. And it just works. And I can fill some other name in, like, hello, my name is Refill, Mikael, I don't know. It just works. And you think, okay, but this is a compiled language. This is going to be much more difficult with development. Like with JavaScript, I'm just used to that everything magically works and gets replaced, and I don't need to reload my browser. Well, in here I can just change some text as well. And it will recompile, of course, but that's quite fast, and it will automatically update. So it's an ecosystem which is already building out over years. And to convince you a bit more about that, we showed Next.js early this morning about server-side rendering, server actions. These are like modern features that we want to use to make our lives easier, to not have to think about forms. These are all available. These just work out of the box. You can make an entirely full-stack application with one single code base using WebAssembly. And that doesn't mean, of course, that this ecosystem is perfect. This is still very new, and bundle splitting is a lot harder, but there are functionalities in WebAssembly that can make that happen. Not a Rust talk. I have shown quite a few Rust frameworks, like Vue and Leptos are both Rust. But there's also, for example, one big one from Microsoft, Blazor. I can't tell you a lot about Blazor, but this is a Microsoft-backed framework which runs entirely with WebAssembly, which allows you to write C# code for the web. Their idea is that now the backend developers can finally start writing front ends. I don't know if that's a good idea, because there's a lot more to web development than just writing lines of backend code, but that's them. And then finally, the last frontier, the madman. Can we take this one step further? So we've written an entire website in Rust. What kind of ideas are out there to continue with that? And if we look back about these ideas around WebAssembly, it's hardware independent and it's platform independent. And the most important there is the platform independence. We've been running this on the web right now, using this glue there, but that can be anything. WebAssembly doesn't have to use the browser, it doesn't have to run in the browser. It can be whatever you want. It can be the operating system directly, if you have an operating system which supports WebAssembly. It can be some kind of cloud service which has an API like create container, destroy container, that you can have a WebAssembly container running that. A light bulb. Do you want your light to be controlled by some kind of program, and your light bulb understands WebAssembly? Just give it a WebAssembly program which controls your light bulb, and now you can party all night. And probably the most interesting of these is Microsoft Flight Simulator. Because they want a safe way that you can create plugins, like create new planes, create new interfaces, create mods for a game, which needs them to be able to actually turn a profit. But they don't want you to allow you to just write random code that will run on someone else's machine. So using WebAssembly instead, which they create an interface like, oh, if you want to make a new screen, yeah, you can do that. They define exactly what you can do, and then you can just distribute all these plugins of WebAssembly, run them safely, it works. It's a bit weird to say, but WebAssembly is actually neither web nor assembly, is the famous quote. And this is even just the beginning, because there have been very strange things which I found on the web that run on WebAssembly. I found an x86 simulator, so now we can run any x86 program, which means, wait, we can now start using Linux in the browser. So you can actually just run the whole of Linux. They even made the graphical interface work. I don't know how they did that. And if we can use Linux in the browser, we can start a browser in Linux in the browser, which you can actually run x86 again. And Linux. Okay, we can continue on. You can also, there's also a port of SQLite, which runs in WebAssembly, not even a port, officially supported version, which runs in a browser. So we can use SQL in the browser, which means, what if we just, instead of making an actual offline web app, we can just export our backend to WebAssembly, make some kind of glue that connects everything together, add an SQL database to that, and suddenly you have an offline app. Terrible idea, but it would work. And probably my favorite project that I found that actually uses WebAssembly is one to bring back Flash. Ruffle. This is a program that finally makes it possible again for us to go back in time to 2005, or I don't know when you guys were young, and start playing Flash games again. And I'm going to open it right now. They even have a demo. Oh. And your old favorite Flash games finally work. Yeah, I'm not going to play the whole game. That's going to take a long time. So, should you start using WebAssembly? Almost. Because this all looks really cool. I've given some arguments at least, but at some point I thought, okay, let's make a JavaScript version of my 1.6 million tweet reader. So I did. The JavaScript version. This is basically the exact same implementation, exact same type of code. It reads my tweets, it searches through the tweets, and I can query the tweets. And I can just simply replace the code here, serve that. This should still be running. I can again open my 240 MB file. Oh. The Chrome developers have done a really good job. And this is partially because my Rust code was actually kind of terrible. There's a lot of copying. But this does mean that you don't need to use WebAssembly for everything. There are certainly operations, very expensive operations, which are very good to start using WebAssembly for, to port to. But this glue, which I'll show you, makes things a lot slower. It means that a lot of memory copying is going on whenever we talk between the real world, the DOM, and JavaScript. It's a kind of overhead, and that costs something. So if you have an expensive operation which can run in the background, then that's very useful, but it doesn't mean it's not much faster than JavaScript, or not for this application at least. And next to that, I've shown a library, which for me at least looks really good to start writing a website in. But this is still a very early days for that library. And that means that every time a new version comes out, it turns out we have to rewrite the entire stack. Oops. So for playing around, yes, please start using WebAssembly. It's really cool, and you can use whatever language you like. We can finally start using your favorite language in the web. But for now, let's just play around. Thanks for listening. That was my talk.
So I was instructed to say that in 25 minutes we will all meet in the Palmsalen. So that's 25 minutes from now. That's it. Thank you.